see if it'll start. Okay. Yep, looks like the YouTube stream is starting and still has the wrong name. Very annoying. That's fine though. Memory allocators. I'll put a parentheses around that. Just changing the title really quick. There we go. YouTube looks like it's working now. So if anyone's hopping on YouTube right now, hey yo, I'm just starting up the stream right now. Just bear with me for another few minutes. Okay, I think both are on. Let me go ahead and test the chat, and then if that works, we'll go ahead and start. Okay, YouTube is still messed up. Sometimes it is, though. Let me check my settings on that, actually. So that's not one. Chat. Yeah. Settings. Okay. I mean, YouTube looks like it is connected, so let me test it one more time. See if it'll figure it out. I don't know. Okay, well, it might just take a minute, so I'll go ahead and start the stream. If it's still an issue, I'll go back and check it. All right. Let me fix my mic. Hold on. Okay, that's something was broken. I don't want to repeat the last time where the mic was muted. Kind of awkward. All right. Okay. Let's go ahead and start the stream. So, welcome to the Game Engine stream. Today is March 28th, another Friday. Yeah, let's go ahead and get started. All right. So, another day, another dollar. You know, you know how it be. All right. So recently, particularly for the Cargano game engine, I've been working on the network code, and specifically for the network code, I've been working on, how do I say, the separate little network playground project that I have on my GitHub. I've made some progress with it, and I feel like at this point it is ready to migrate into the engine. So I will do that, but I am going to do a little bit of kind of preparatory work before I actually migrate it in. And that preparatory work has been me kind of just reading about design patterns and looking into like memory allocators and, you know, stuff like that, code structure, because I want to try out a new way of putting together the code. And I'm going to test it out by implementing it with the network code, if that makes sense. So that's basically what I've been doing. I've been reading 2 books on design patterns. I'm almost finished with the first one, and I've been reading kind of sparingly through a second one. And I have a few resources I've been learning memory allocators from. And particularly today, in today's stream, we're going to be working on creating a few memory allocators for the engine, just to have, right? So I'm going to build these up first, and then I'll figure out where they're going to end up being useful in the engine. But I'm just planning on doing the basic allocators, like a linear arena allocator, maybe a pool allocator, a stack allocator will be nice too. Maybe like adding some free lists would always be nice. So I'll get into it when we get into like the main parts of the stream, right? But yeah, I think that's all I had to say about that. So let's go ahead and get into the progress board, and then we'll go ahead and start. Okay. So nothing has changed with the progress board. I'm still doing the networking thing. So still writing this up. If I recall correctly, I put a few notes in here. Or maybe I didn't. Yeah, I completely rewrite the networking code using UDP BSD sockets. Yeah, I mean, I think that's pretty much done. Maybe I'll put an extra note. I'll say done. And the next one will be migrate the network code into the engine. Okay. So this is the next step for this one, right? Yeah, and then I guess I'm still going to be kind of refactoring as I go with this, but yeah, we're still in the middle of this. I know this is taking longer than I kind of said it would, but I think it's good that I'm reworking it now and figuring things out. Okay, but I'm going to add a few new items. So the first one, or maybe just one for now, I'll say memory allocators. And maybe I will put this in networking issues actually, yeah. So we'll make it an issue. Hash description. And then we'll say create memory allocators for use in the engine. Yeah. Oh, no. I can't tab. Quotes. What does this do? Oh. Okay, that's kind of cool. I really can't tab. But yeah, if I preview the markdown, let's see. If I do 2 spaces. Oh, okay, that works. Cool. What about 1 space? What does that do? Oh, it does nothing. Okay, so it has to be 2 spaces for a quote-unquote tab. Sure. All right, so a linear allocator, i.e. arena. I do want a stack allocator just to use. These are always good. A pool allocator would be nice. I'll stop for now. I'll stop there for now. I have a few other places I want to like go with this, but this is a nice initial list. Okay, cool. And we'll bring this up to the top. All right, looking good. Memory allocators, nice. So that will be the goal for today, right? So I'll go and get into this once we get really into the stream. But right now I want to cover what I've done before the stream, right? And I haven't really done any coding on the engine, or I don't think I have. Actually, let me go check. Maybe I have. The week's kind of a blur for me, to be honest. Yeah, no. So I haven't done any coding because this was what I committed at the end of last stream. So that's as far as the engine, right? But the little network playground that I made, I did code, and I didn't really put too detailed of like a commit message for these. I apologize if anyone's trying to follow along. But I'm kind of just coding this because I put in like 1,000 lines. I've just been kind of working on it gradually, and I just do one big commit. So I know that's not good practice, but I don't know. I kind of view this as like a side thing instead of the actual engine. Probably should have just done this on a branch of the engine. Yeah. maybe next time I do this type of thing, I will just make a separate branch and go from there, instead of making an entirely separate project. So yeah, lots of code. I think what I'm gonna do, I'm just gonna maybe just take a look through the code on my local repository, and then I'll kind of just explain like some of the changes I made, but I'm not gonna go too deep into it. All right, if I recall from last time, all I did was add the reliability module. So that would be this reliability context. I might have renamed it, or maybe it's the same thing. No, I think it's the same thing. Reliability context, right? This one, yeah. I actually did a little bit of, what is it, the components design pattern. So I've just been breaking this up into like individual pieces, right? Round trip context, congestion context, and the sequence stuff is pretty common to all of them. But it still functions the same. It's just I just been reorganizing this. Oh, Kozo too. Hey, thanks for the follow. Appreciate it. Yeah, if anyone has any questions or anything, just let me know. But I'm just kind of doing a little recap right now. But yeah, I appreciate it. Hell yeah. Let me get a little sip of coffee real quick. Oh, you know what? Wait, bear with me for a second. I'm gonna BRB like 1 minute. I want to make sure I have a noise that plays when someone subscribes on YouTube. It's really easy. I think I had that problem last stream. I forgot to deal with it. Twitch follow. Yeah. Okay, here we go. Add YouTube follow. Okay, let's copy this. Which channel follow? Okay. New subscriber. Okay. Okay, core sound. Play sound. Keizo? I don't think so. I mean, it sounds kind of familiar though. I might take a look. Is he like a... Wait, is he the Twitch streamer? I might have that wrong though. I'm just trying to find this audio file real quick. I think I put it... Okay, oh, hold on, this thing is loud in the background. Let me close my window. Okay, there we go. Surprise. Let me see. Wait, application streamer bot sounds surprise. Wait, just give me a sec, sorry. I'm just trying to make sure this audio file is lined up properly. Streamer bot sounds. Okay. Follow YouTube. Okay, I'll deal with this later. It's fine. Alright, let me go ahead and close this. Okay, I'm back. Oh, are you really? Keizo? That's a big Twitch streamer, right? Let me take a look. I'm curious. Let's see. Kazo2. Oh wait, no. Kazo2. Oh, it's K's O, right? Oh, I got you. Well, for sure. Yeah, I don't know much about, but I mean, if you are, like, thanks for coming by. I appreciate it. My streams, I don't really go too crazy with them, so it's kind of just chill. But yeah, I'm just going over some of my engine work I've been doing, So I mean, yeah, feel free to chill, hang around, Yeah, this commit message is garbage. Okay, so I think I was looking at what I worked on recently. So basically, yeah, I just been doing a lot of refactoring, just taking components out and putting them into their own little sections instead of having this giant liability context. And then what else did I do? Let me see. I think I just did some structuring on like my server and my client. And okay. I recall now. Yeah, I'll go ahead and explain it. I thought you were doing hacks. Oh, no. Like, yeah, I never got into that whole, like, scripting and putting together mods and, like, putting together, like, tools for, like, working with games. I just know my C++, Like, there's like a whole rabbit hole you can go down with that, huh? I mean, I would love to know, It seems interesting, but yeah, it just seems like there's not a lot of guidance on how to, like, get to where you want to go in that space. Unless you have, like, a very specific thing you're dealing with, But yeah, okay. Oh, well, you know what? Let me take a look. So let me just explain really quick what I did for the server. So the server basically, right? Last time you were able to start up the server, and then you can start up a client, and then you can go ahead and start sending messages, right? But the issue was that both the server and client were running a hot loop, right? Which means we're polling the CPU continuously, and that burns up like cycles or whatever. Like it makes your CPU work extra hard. And if you're running like a client, like the actual game context, then you would want that, right? But if you're hosting a server on, say, like a VPS, so like you're hosting it somewhere else, you want to minimize the amount of cycles that you're using, right? So what I did is I restructured the code on both the server and the client side to take in asynchronous polling instead of doing like a hot loop. So now what happens is we have basically two threads. You have the network thread and then you have the event thread, right? The network thread does all of the work. So it processes receiving bytes for or receiving packets for messages. And it processes input. It does it through through an event queue. Before this, I was just polling them directly. And the big change is instead of doing this continuously, after we finish a loop of this function, down here at the bottom of the function, we suspend the thread, and then we wait until something wakes the thread back up. Yeah. So the things that can wake up the thread are, well, in the case of the server, it's either a network event, which is this, or an input event, which is here, right? So this is like console input, like if you type into the actual console. And then this is just receiving, basically, when there's a message ready on the UDP socket associated with this server, this picks that up, and then we resume the thread, and then the actual network thread can go ahead and handle that. So basically the network thread isn't doing any work until it receives a message, then it'll spin up, deal with the work, and then close back down, right? And you can kind of see this in action. I'll go ahead and run the server. Oh yeah, and I guess I didn't really say specifically. Here, this is the event thread. So again, we have two threads. The network thread is what actually handles all of the work, and the event thread just waits on this function call. It just sits here and it waits until something happens, and then it'll wake up and then submit the event so that the network thread can pick it up, and that's all that happens. So if I go over to, let's see, over here, the server is running. Let me open up a client version of this. So let's open this. Oh, and also I post these videos on YouTube, so I'm just kind of like going through my normal steps, you know what I mean? Let's see. Okay. All right, so network, and this one's gonna be client. Okay, so this one's connected, just automatic, right? And then we're gonna go over here. All right, now we're gonna say hello or whatever. Cool. And basically, if we look over at the diagnostics, we can see that this core is running right now. And essentially what happens is when there is a connection, like an active connection, we do want to actively poll. So if you go back over to the server code, if we are managing connections, as in there is one or more connections, we want to start sending keep alive packets to keep the UDP connection alive. Yeah. So this just checks that every run and continues. But what you'll notice is if I close out of this connection, this client, again, there's only one client, so we're going to go ahead and exit out. I forget if I fixed the input. I don't really care about the input for the client because I'm going to integrate it back into my engine. So let's just close it. And what happens is the server is going to take a second to recognize that the client doesn't work anymore. It's like 10 seconds. But once it does, it removes the client, and you'll see way over here, the CPU drop back down to 0. So now it's back in that like original state where it's just waiting for events and it's not doing any extra work, right? But the moment one client connects, so we'll go back and run this again. And let's get this out of the way. /network client. Okay, we're gonna spin it back up, and then you'll see if this thing's still alive. What is it doing? Okay, here we go. I guess it's just not following it. But what happened is it was off, the client connected, and now it's polling again to go ahead and keep the connection alive. So again, that's just so that when I'm running the server on like a VPS, I'm not hogging a bunch of CPU cycles unless something's actually happening. And that's it. So yeah, yep. That's mainly what I did. Otherwise, I just did a lot of refactoring, so just cleaning up the code and whatnot. If you're curious, you can take a look at the commit. And if you guys have any questions or whatever, just let me know whenever. I know I didn't go super into detail, but I just wanted to kind of recap generally what I did. So the next step with the networking code after this is I want to, again, go ahead and integrate it into the engine, right? But I've been kind of on like a design kick recently where I've been reading a lot of like design patterns and like kind of learning how to structure my code better. And I'm kind of taking this network code, this new network code that I'm going to go ahead and put in as a chance to clean up my designs and make sure that like I can try out some better designs inside the network code and then maybe move that to the rest of the engine. So I've been reading this book, Game Programming Patterns. This one's really good. If you ever read Learn OpenGL, he links to this book. It's really nice. But it just takes you through a lot of design patterns for like game engines, like specifically, right? And also I've been looking into like memory management. So if I go over to memory, custom allocators, data-oriented design. This one's really good, but which one am I really looking at? I think it was this one. Oh, this is the GitHub. Wait, just give me a sec. I gotta open up my Reddit. I think I have it on there. Also, my bad if I'm talking kind of fast. I just drank a bunch of coffee. I'll try to slow it down a bit. I've been trying to be more mindful of that recently, but you know, sometimes I get excited and I just start talking, you know. The arena custom. Okay. Oh, it's not loading. What? It's probably because I'm using a VPN. That's annoying. All right, whatever. But I've been looking through this guy's right here. This guy's series of posts. He just talks about different, or lists a few different memory allocation resources. There's also some other places I've been looking to, but the Handmade Hero playlist is really nice. Although you kind of have to dig through what he's working on to kind of get the gems, but it's really good. He has a lot of advice. It's good. But specifically, I've been working on this. It won't load because of my VPN. Let me try a different site. Okay, let's try that and reload it. Oh, use Ethernet? Nah. In my house, there are some Ethernet ports, but not in my room, so. Yeah. It refuses to load, huh? Okay. I'm gonna make an exception for this one. But I am gonna block the screen just for a second. Okay, let's open this up. And open this in a separate browser. Okay, this might blind you guys. I just make sure there's no information about me on here. Okay. I'm a little paranoid, but you know, it is what it is. So this website is really nice. I'm only gonna open up for a second, but we're gonna come back to this. He goes through and kind of shows you the code for different types of allocators. So this one's a basic linear allocator. Here's a stack allocator, a pool allocator, you know, and free list, and then buddy allocator. So I'm going to be going through maybe writing these first two today. I'll see how long it takes. Oh, for sure, Kazu. Hope you get some rest, man. Thanks for coming by. Let me see. Yeah, so we're going to be going through this today, right? And yeah, this has just been what I've been researching recently. Oh, for sure. Well, I post these streams on YouTube, so if you ever want to take a look, but I only stream once a week, so. But still, I appreciate you coming by, though. Let's see. All right, so yeah, I guess I was just kind of rambling about what I've been learning recently. But yeah, again, that was the major changes I wanted to show you on the network playground side. Again, if anyone has any questions, I'll be on the stream for like 5 hours, so just feel free to throw a question or whatever at any point. But let's go ahead and get into the main topic today. Where's my thing? Okay, so memory allocators, and like I was just saying, that's what we're going to be working on. I already started working on like a basic, kind of like a test run for the memory allocators, but I'm not going to keep that. I was actually using what is his name? Jacob Sorbet. This is cool for like C programming. Yeah, I don't want to get left out here. So I've been going through his basic like object pool, and he uses a free list along with the object pool, right? So that's pretty cool. So that's been kind of getting me like a chance to try it out, I guess. That's what I've been doing with this. But yeah, specifically, I am going to be going through this linear allocator. Again, maybe it'll load this time. Let me try one more place on my VPN. So annoying. Okay, let's try here. Usually this one works. Okay, this one worked. Okay, cool. All right, sick. That's good too, because you guys don't have to get blinded by the the website. But yeah, today we're going to be going through this linear allocator, so I'll be reading through it. I kind of already know what is going to go on with it, but I still need to kind of go through it, I guess. And yeah, we'll just be building this out. Let me check my little to-do list, make sure I didn't forget anything. Okay, all right, let's go ahead and start. All right, the linear allocator, the first memory allocation strategy. Yeah, as far as I understand with this linear allocator is that you just stack them on top, right? So you have like a starting, and it's very hard to see here because the colors blend in, but you have this memory block, and then you start, you have the current offset, and then you just stack onto the end of it, right? And then if, how do I say, if there's an opening or a gap inside of the memory block, you just ignore it, right? Because the lifetime presumably is tied with, like the lifetime of each individual allocation is presumably tied with the lifetime of this entire allocator, right? Now that's a big assumption, right? Like there are definitely instances where that's not true, and then we can deal with that. But the nice thing about this is if we keep this very simple and we don't really plan on deallocating anything, or if we are going to deallocate it, we're going to take this whole chunk and get rid of it, then you really don't have to worry about the holes. And then you can also just keep data that's not necessarily, what is the word? Fixed sized, right? You can do like various sizes and you don't have to worry about it. And it's just a very simple, like, you know the constraints, you use it, you keep it moving, right? So yeah, the arena's logic only requires an offset to state. And also, I'm just going to be writing this code in. It's not going to be perfect, and then I'll go ahead and iterate on it over time, or while I progress, I suppose. All right, to allocate memory from there, as simple as moving the offset forward. Yep, constant time due to being the smaller allocator. Yeah, and the main thing about this one too is you really want to know how big your allocation is going to be up front, right? So you don't have to keep moving it around. Ideally, you would just put the memory in and then you forget about it. Okay, so yeah, here's a basic implementation of it. I believe this is the actual like allocation, like you're allocating a block, right? So here we have the arena buffer, right? This arena buffer is the actual arena, so we're doing it statically. We wouldn't do it statically in the actual engine. I'm assuming this is just for example's sake. So there's the buffer. There is the actual length of the buffer, and then this is the current index into the arena where we want to go ahead and keep adding, how do I say, data into it, right? And the basic algorithm, right, is assuming that the buffer is already allocated and we're all good. Yeah, we check to see if there is space left, which is basically, we get the arena offset, the location in memory, and then we add the size, right? And then that should, like if that overflows the size of the buffer, then we go ahead and return null, right? Otherwise, we'll go ahead and do all of this mess to basically get the pointer to that location in the buffer, right? If, you know, we have enough space. We, you know, increase the size because we're adding new memory. And then in this case, we're zeroing it out. I know there's a lot of, I've been reading a lot of strategies for how you do want to set this memory. Maybe you want to default set it with a certain like pattern for like debugging purposes. But I guess for now, in its basic sense, you just do a memset 0 and call it a day, right? And then you can go ahead and initialize whatever you need to initialize on top of this memory that gets returned back. So as you may tell, it's as simple as it gets. You cannot reuse this procedure for different arenas. The pointer return may not align correctly to the data. Yeah, I think I was really reading this too, that there's two issues with this. Is that, yeah, you can't reuse this. It zooms in way too far, maybe I should fix that. But yeah, you can't reuse this, and the pointer may not align correctly. I think I saw this somewhere else, where you want to make sure that you're aligning to whatever the hardware aligns to, right? So if you have like a 32-bit versus 64-bit architecture, right? You want to align to the word size of that architecture, right? Because otherwise you'll be accessing memory in like a very weird, skewed way. It's going to be very slow. So that's what this paragraph is just saying. So in order to address that, let's see. On virtually almost change the amount of bytes that something must be aligned. Line B must be a power of 2. Means we should create just assert that the alignment is power 2. I might not worry about this just yet. I'll go ahead and add this as like a addendum, I guess. To align a memory address to specific align a simple modular arithmetic to find how many bytes forward you need to go in order for the memory address. Yeah. Yeah, I mean basically modulo, yeah. So assert is power of 2. P address is not aligned, push the address. Yeah, so you just find a remainder, and then if the remainder is not 0, we just move it over by whatever the offset is. And that's all it is. Pointer. One thing I'm trying to understand, let me read this for a second. We assert here, pointer, align. Power 2. Okay, so we're looking at the actual number of the pointer. And then we want to shift it over. And you return P so it's aligned. You know how to align memory. That means we can update our original alloc to support alignment. Okay, so we have that function up somewhere, right? Yeah. Arena alloc aligned. Yep. Oh, because they don't have default parameters. Sure. Oh yeah, I forgot C doesn't have that. So we align it first. See if the back memory has space left. 0 new memory by default. Okay. Yeah. So again, we still have that, and this time when they put it into a struct, that's even better. So now it still doesn't show how we're allocating it, but I'm assuming at the end they just say real quick, this is just a bunch of helper functions. But they say you can just use malloc and get the actual buffer back. Or in this case, they're just providing a stack allocated buffer, or I mean, yeah, the stack allocated buffer, right? But generally speaking, we'll just do malloc and just remember to get rid of it. Maybe you could do both, actually. This might actually be a good option. We'll see. We'll get something working first and then go from there, right? But yeah, just make sure that when we do the individual allocation, not the big buffer allocation, but the individual like allocation from the arena, right? We align it first. And then we do the backing check, which we did earlier. Return it, if not, return null. What's up with this? Default alignment. 2 times size of the void pointer. Oh. So on a 64-bit, this would actually be 128 bits. Or 16 bytes, right? But on a 32-bit operating system, this would be 64 bits. That's interesting. So that's what you wanted to align it to. Okay. Yeah, and then again, the rest of this is just initialize the arena with the pre-allocated memory buffer. So that's kind of what I was talking about at the bottom of this page with the malloc and everything. Simply increments an offset to indicate the current buffer offsets. Yeah, so this actually grabs the memory, which is based like this function is basically this with the alignment and whatever. Free does nothing because for linear allocator it's just simple. You don't really worry about that. And then resize. Was the previously performed allocation. Yeah, what are we doing in this case? First, check to see if the allocation being resized was the previously performed allocation. If so, the same pointer will be returned and the buffer offsets changed. Otherwise, okay. So you're taking in like an existing buffer and then basically just reallocating it. Maybe I don't fully understand that one, but I'll come back. But I mean, I get the intent, I just don't understand like the implementation. Arena free all is used to free all the memory within the allocator by setting the buffer offset to 0. Okay, that's nice. That's nice. So this frees all of like the internal memory, but keeps the buffer alive, the arena alive. So yeah, this has nothing to do with the init. I will want to add a terminate. That would be nice. But this just allows you to overwrite whatever memory was previously in there, and then just continue. No, that's a nice feature. So backing buffer. Okay, here you provide the backing buffer. Okay, that's interesting. Oh, yo, thanks for the follow. Cracks BF. Let's go. If you have any questions, just let me know, or just chill, you know. But I'm just working on adding some basic memory allocators to the engine. So right now I'm just doing a linear allocator, just figuring it out. Yeah, how's it going, man? Hey, yo. Yeah, arenas. Yeah, so just basic arenas for now. I'm going through this list of, let's see, what if I can go back? It just takes me back here. Yeah, I've been reading up on like memory management for a few different, or I guess I'm just jumbling my words now. But yeah, I think I'm just going to do some basic implementations of linear, arena, stack, pool. I'll just get them all in right now, right? There's only 6 of these articles. And then once I'm done, I'm going to, just go from there. Add some things. But basically right now I'm working on my networking code. And I'm trying to give myself some tools to restructure my code. And one of the things that I really want to start using is allocators. So that's why I'm here. So right now my networking code is ready to migrate into the engine, but yeah, I just want to give myself a chance to try out some new code structure. And yeah, I just read through most of it, so I think I'm going to start doing the basic implementation of this, right? As far as I understand, right, the first things to get done are arena init, and then maybe a terminate, right? Here, I guess you provide the, yeah, you can either do like a malloc, right? So maybe you can do this internally, or you provide like maybe like a stack allocated backing buffer, right? So they kind of give you the option if you want to go either way. I'm just going to assume malloc right now, just because that makes my life easier. So I'll go ahead and implement that and get the basic buffer created. And the next thing is just to create a basic allocation algorithm. This has a lot of bells and whistles, right? And I'm not really going to worry about alignment right now, even though I know that's important, but just for simplicity, I'm going to do this basic implementation right here. For just, adding some memory, move the pointer, right? That's it. And if not, just return null. So let's get into some coding. Let's go ahead and start making it. Let's see. All right, if I can find my memory section. Here we go. All right, and don't mind my previous attempts on memory. I was just trying some stuff out. I'm gonna erase this later. All right, so we'll just call this. I'll just do linear allocator. Do I want it to be a class? Yeah, I mean, we're in C++, so might as well. Linear alloc. I do want some stateful functions, so makes sense. Okay. All right, so again, what's the main meat and potatoes of a linear allocator, right? First thing is the actual data buffer, right? So what did they use for the C implementation? It was like a unsigned... I might just do a U8 underscore T pointer. Where did it go? There was that struct they had. I kind of want to see. There it is. Okay, so they have an unsigned car. Yeah. Yeah, I'll just do a UN8. And they have a size T for the length. Yeah, that makes sense. I'll do a size T too, since that follows the hardware, right? Sizes. And yeah, this is for previous and current offset. I'm just gonna go with offset for now. Let's not make this complicated. So should include cstd int. All right, int 8 underscore t pointer. I'm gonna call this m underscore buffer. Yeah, and we'll set it to null pointer. Just I like doing my I don't like having explicit constructors. I like just doing this. Okay, and then we're gonna do a size t for the m buffer size, or I'll just do m. Yeah, actually I'll say buffer size, because it might be opposed to something else. What's the default value for the buffer? I like doing explicit, like, invalid values for these types of things, but I will just do 0, because if it's 0, you can kind of assume that it's just not valid in that case. This is one of those situations where 0 actually just means 0. M underscore buffer. What is that? Offset. There we go. Offset will be 0 as well. Okay. And let's go ahead and start adding these functions. I'm going to pull up this page on the side for myself. So I'll just be reading off of it on my other monitor. Okay, I just want to see what functions make sense to implement. Where was that list they had? I lost it now. Okay, here it is. Okay. So I like having an init, so we'll do void init, right? We'll take in some stuff, but I'll keep it like that for now. Terminate. I feel like release makes more sense, but in my engine I kind of have like an init terminate like situation going for everything, so I'll just keep it the same. And where's one of my little organizers? Okay, don't mind this code, I was just trying some stuff. And here's the old networking code. What's up? Yeah, how's it going, man? I see you be popping in sometimes, so thanks for coming by. You know, I really should get some of those emotes to work in the inside of my thing. Maybe I'll look into that. But yeah, it's nice seeing you. It's been a while. Well, don't the different streamers have I don't know, they have like chat commands that'll like you can do a wave and then it'll do something in the stream. I know they have different programs for that though, so I don't know. Maybe it could do something on the screen. That'd be cool. All right, let's see. Let's do life cycle. Oh yeah, Emblem whiskey. Nice to see you here. First message. Heyo. Yeah, I just started, so I've been doing a lot of like reading the past week on it, and this is like my first starting into it, right? I think everyone starts with linear allocators, the arena, right? Very simple. So I'm just getting the starting functions set up. I'm using this website, and I'm just kind of going through the motions with it, getting this API working. So yeah, it's coming along. Let's see. Lifecycle functions. Let's see. Yeah, I like having explicit like init and terminate functions for everything. That's just my preference. I know it's a lot to remember usually, but and I suppose if I wanted to do like RAII for this, I could maybe do like a wrapper or something on top of this that does something in the constructor and destructor. But yeah, I like having explicit calls for these things. So let me move this up here. We'll do constructor. Yeah, I just have had like, I feel like my engine currently doesn't really have a lot of structure to it. It's a lot of singletons and a lot of just me getting things to work. So recently I've been trying to get a lot more thought into how I deal with memory, how I set up my designs and everything. So this is kind of what that's where I'm at with this, I guess. Let's see. Allocators, what is this intended for? Looks like network communication, or is it general purpose? Well, the linear allocator is more general, right? I'm just gonna go through and just build out some basic allocators and then see where it makes sense. But I am working on networking code right now, so that will be used soon. I don't know how long you've been in the stream, but I was... I wonder if I can find it. Oh, there it is. I was like, where'd that thing go? Dev. All right, let's find it. So this is the engine Cargano, right? I have links to it and whatever if you want to look at it. But yeah, code's kind of messy right now. I've been realizing that slowly. But I've been rewriting my network protocol. Right now I use ASIO for it, but I've been switching over to just using like POSIX sockets. So that's what this little playground is. And it's basically working. So my next step is just to integrate it into the actual engine. Oh, for sure. But yeah, that's basically what I was talking about before you came in, was the work I did on this. And the fact that I'm pretty much... Well, actually, I think I have it in my updates too. Let me open my updates. Yeah, the network code is ready to migrate. So just cleaning up some stuff so I can get it in. Where does this thing go? So yeah, just linear allocators. I'm very new to this, so I'm not like a, I don't really know a ton about this. I've been researching, but learning as I go, type of stuff. All right, so let's get these constructors. Again, I don't like having a bunch of stuff happening in the constructor. It's very confusing for me. So I usually just make these defaults unless I have a reason to do otherwise, or I have like an object that makes more sense to have a constructor and destructor. But I think for this, with the linear allocator, it makes more sense for me to explicitly set it up. Especially since the basic version of this is going to just use malloc. Yeah, I think I might figure out some way to get... maybe I'll put the circular queue as like a separate class as well. I do use a circular queue in my network protocol that I just wrote. Maybe I can kind of show you too. I feel like the moment I used that, I felt so smart. I was like, I mean, I had to research to find it, but the moment like I saw it and then they explained it and I used it, I was like, wow, this is so much better than what I was doing before. Where is it? Network config, network common. Where is it? It's in my reliability context. So here I have like, this checks for congestion. This checks for round trip times right here, right? And where's my circular queue? I think it's this one. Yeah, so I have this array right here. And it's just a bunch of like floats, which I could probably compress this more or do something, but it caches like when I sent the message, and then each of the messages has like a sequence number. And when that message is act, right, when it gets sent back, it indexes into this like circular queue, and then like confirms like the round trip time. Yeah. So yeah, when I got that working, I was like, this is so good. It's just a modulus check, and that's it. Love it. All right, so yeah, that's default. Yeah, so yeah, I feel you. I feel you. Yeah. Let's see. Okay, let me figure out what other functions make sense for this. So init terminates. Right? Yeah. Again, I'm pretty new to it, so I'm like a lot of the stuff was handled by Asio when I was doing the original network implementation. So building some of the stuff myself just felt like so satisfying. Oh, overflow. Oh my. Well, I think, yeah, yeah. Let me not speak too soon. I gotta add more. When I finish moving in the network code, I will add a lot of fuzz testing, and whatnot. So I'll see what issues pop up. There probably will be an overflow. All right. So lifecycle functions. Let's see. Allocate memory. I might have a few different ways to allocate, but we'll just say allocate, right? This will return a look at this thing. I mean, it's going to return like a byte buffer, right, with the size. So you would provide. Actually, let me see how the C does it. Allocate a line. Allocate to C. Okay, yeah, so you provide the arena. I'm just reading off on the side of the screen real quick. Make sure I get everything. Size. Okay, and it returns a void pointer, so that's going to be the memory itself. Yeah. Okay, that makes sense. So you indicate the size and you can get back what you asked for. That makes sense. So I'm going to do uint8 t pointer. I just like having that. Allocate. Maybe I could do like alloc. Sure. I like my names being very long, but whatever. It's an allocator. Probably figured it out, right? This provides the arena and the size. So I'm not providing the arena. It's going to be this is a member function. So all I have to do is provide a size. So data size. Okay. Okay, and again, right here in this little thing I'm reading, it says that it doesn't do anything, and yeah, that's the intention of an arena allocator, right? Is that you just allocate the stuff, and then when you're done, you just drop it, and all the memory aligns with it, right? So I think I'm just gonna not implement this for now, and then I'll come back and add it if it's really that necessary. But yeah, it just doesn't make sense with the API, to be honest. And I'll add free all. That's always nice. I think I'm gonna keep it simple too, and just do the alloc, and then like the intention is just you're just gonna allocate and then free, right? So we'll just start with that, and then I'll add more stuff later, right? Right, it might invalidate it, yeah. So you have to like do some management, or I guess in this case he's saying like you just find the next part of the offset and just add it on top. But yeah, that's an interesting API. I don't think I would be using that. So yeah, free all. Well, what else do I want? Free doesn't do anything. Right, right. Let's see. Yeah, yeah, like you know exactly those constraints, yeah. Right, right. Let's see. Okay, so I'm gonna do free all. Let's do free all. That's a nice, easy thing to do. Allocate memory. Free. Does that go in life cycle? No. Okay, I'm gonna throw it in life cycle, I guess. Manage. I just like having these big labels. Makes it very easy for me to find what's going on in the class. Manage arena. Yeah. And then this will just be a void. Maybe a bool if it fails, but I don't know why. No, it shouldn't fail. You just return. You just go back to the original pointer. So clear. Right, because that behavior would just be weird, right? Yeah. Ooh, I really want to add some nice. That was the other thing that got me excited about arena allocators too, is because you can add like a bunch of visualization for it. That's really fun. I want to see the little boxes popping up, and I can like see how much memory I'm using for every system. That'd be really cool. Let's see. I don't know what to call this one. Free. Okay, I'll just call free all for now. I don't know. Reset. 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 Yeah. Reset. Init. Reset. Struct. Alloc. Oh, okay. Yeah, I'm just reading the little things you put up earlier. And then struct is according to length. Right, yeah, and then you just write over it. No need to do anything else. Okay, yeah, I think this is good. I think this is good for me. All right, so let's go ahead and implement it. Let's see. All right, I'll just copy that malloc thing over from the code. Might as well. Where's it at? I never like explicitly used malloc. I'm very C++, so I always just use like pointers and unique pointers and whatnot. So this is very new to me. But yeah, word pointer. So arena A is equal to 0. What's going on here? Okay, and then they initialize with the back buffer, right? But here I'm just gonna be doing explicitly. I might want to add some like asserts for now, just to make sure that I don't misuse this though. Let's see. Should I? I don't know. We'll see. We'll just put it in for now. Do I have to include anything from malloc? Does anyone know? Never used it. Oh, you do? Oh shit, okay. What is CSTD? CSTD in lib std lib. Let me check out this header file anyways. Oh, it's not in the source path. Right, like from some other header file. That makes sense, yeah. Oh, it seems like I found it. Just my Visual Studio just not knowing how to open links. Where's the sometimes I use this thing. Hey, there it is. Oh yeah, they have everything here. Env exit. I know I'm going on a tangent, but I kind of want to look at this header file. What is this? Just for my own curiosity's sake. Because it's such a small header file. cstdlib. Several general purpose functions, including dynamic memory management. Oh, this is just... Okay, yeah, these are all those functions for converting things, right? Rand, and then we have calloc. I know what these do, the calloc free, malloc and realloc. I haven't really seen people use this a lot though, realloc. Abort, hex, get env. Kind of a mixed bag, isn't it? That's interesting. C standard general utilities. Okay, I was just curious. Never looked into that before. All right. So yeah, this is not this. We're gonna do m underscore buffer from void pointer of type void can be assigned to it. I mean, it's a data pointer. It should be fine. Wait, no. 8 underscore t. I mean, it gets the job done for like a lot of things, right? I don't know. I haven't used C that much, so, or like pure C that much, but seems like it works. Okay, so here we're gonna go ahead and free. So, what is it? Free? Is this right? I don't know. Yeah, if you init multiple times, that's going to be a memory leak, right? Yeah, and I saw that they were doing that in the example too. They pass it in. Okay. I think I will do that. Let me put it to do, but I'm not gonna do it just yet. Let me see if I want to make sure it works first. So we'll say to do push buffer in externally. Yeah, we'll add this in a second. All right, let's get this algorithm working though. Your calling code knows about it better. Fair. All right, Alec. Let's go and write this in. So, if... Okay, the default case is we return a null pointer. That's fine. Otherwise, if... And we have this... I'm gonna try to freehand it. And then I'll go confirm that I did it right. Just for fun. So we'll do what is it? Offsets plus the size. Yep, so offsets plus size is less than it is less than or equal to. It would be, you could have it equal to data size to, what is it? Offset data size equal to the size of the allocation, buffer size. Buffer size, okay. And then here, allocate. Okay, the memory. Yay. Otherwise, failed to locate. Was it failed to find enough memory? Yeah. All right, and then we'll do a few steps here, but I mean, the main thing is we're just gonna get the buffer, get the data at the offset from the buffer, and then return it, right? Okay, pretty easy. So the end goal is we're going to return m offset, m buffer. And I think you have to do that thing, right, where you want to convert it into a uint, what's that thing, pointer t, just in case, just to be safe. Oh, no, that turns it into a number, what I'm talking about. It stays a data buffer. I'm thinking the other way around. Plus data size. So yeah, I think it's the pointer, and then this is a uint8. So this is per byte. So since it's per byte, it will add per byte, and that's your return. So I think that's good. Yeah. Okay, let me go compare it. There's probably some checks I want to do in between. Yeah, it's nice and easy. Not the big alignment thing. Calling code does better lifecycle memory than the written code does. Plus, means you can abuse resist nest buffers. Oh yeah, that's a good point. You could nest data inside of the. Yeah, that's a good point. That's actually a really good point, and that would be intentional. Okay. Yeah, that's cool. Do you think I should make like a separate function just for like a default memory allocation? I think I might do that. Because otherwise, right, like you just pass in the actual or let me see, let me go find what we're talking about. Yeah, because here I have to call malloc explicitly. Maybe I'll make a function, like a wrapper on top of malloc. I don't know, I don't feel right just using malloc by itself. Or maybe I can make two init functions. I can make one init function that uses malloc, and the other one that you pass in, right? And then for the one that uses the init, I'll have an explicit way to check to make sure that I don't cause a memory leak, right? No, I mean true, but I want to be like really aware when like I forget to call terminate, or I forget to deallocate like the new memory, right? Because presumably, like if I pass this in, right, as like the backing buffer, in this case, I know that I don't necessarily own this buffer. It's more like being given to me. And then, what is it? Yeah, like I don't own it. I just manage it. But in this case, like I'd like to know when I call free. Then create a single arena at the beginning of your program and always suballocate from it. Yeah, you have one big arena. Yeah, and that's the point of the arena, right? Is that you know what the size is ahead of time. And then that way... Yeah, you know, I guess I'm still thinking in terms of, like, small buffers, huh? Maybe I shouldn't encourage that. Mm-hmm. For what you use, due to virtual memory. Oh, yeah. Use due to virtual memory. Here for what you use. I'm just trying to process that, I think. Oh, virtual Alec. Oh, virtual Alec. I haven't seen that one before. Oh, it's a Windows thing. In French. That's fun. Let's do the English one. I mean, yeah, regardless, you'd like to know. Oh yeah, I guess I'm just processing that. Oh, mmap, okay. Wait, let me keep this as a... Any reason to use these over... Wait, let me see. Creates a new mapping in the virtual address space of the calling process. Let's see. Map files writes into memory. Mapping in the virtual space of the calling process. This address is the new mapping. The length of the mapping. Yep. Just null. The kernel chooses page and line. The contents of the file mapping. That is, again, something for the consumer code to decide. Right, yeah. If you're using the code, you probably would want to overwrite it yourself or figure that out. Or zero it yourself if you really needed it. So, what's the reason to use this over, like to use mmap and then the according, like the analogous virtual alec over just calling like new or calling like malloc? Oh, for a socket read, I feel that, yeah. Is it mainly just that like zero thing, or better control? And you call OS. Oh, okay. Okay. Yeah. So, I mean, maybe just write like a wrapper on top of this for myself and then just use the options that I want, and then I can kind of set it up. Yeah, I'm gonna save this, and I might take a look a little bit later. Let's see. Yeah, let's just save this inside of memory, and I'll save this doc inside of memory as well. And I might come back and maybe write a wrapper on top of this. Okay. You know, I really got to get into like OS stuff too. I did an operating systems course in my degree, but I didn't really like get. I don't know. I feel like the course didn't like really take me through everything, and also like I don't know. I kind of just phoned it in a little bit. But I want to go back and really understand that. Okay. I didn't. How can you like work with that? Is POSIX compliance? Okay. Wait, where was that page to? Let me go back to. There's so many tabs. Let's close this. Okay. Let me read through this real quick. So again, that's just basic malloc, and then this one is unsigned car. Okay, and again, we'll do this. And then for the malloc one, we could maybe take advantage of those other functions you guys were showing me. So maybe I'll skip that for now. And again, like you said, just grab a big chunk of memory at the beginning of the application for how much you need. And then divvy it out as needed. Okay. So I guess I'll write the API like this then, and then maybe call malloc explicitly for now. Let's see, free all. Yeah, and here we just said, actually, I can do this right now. Let's write that API real quick. Let's get rid of this as well. Okay, so it's just m offset is 0, right? Wowie. Too long to write in Twitch. I'll send it. I mean, yeah, fair enough. Let me see. I'm gonna block this just for a second. Let me go ahead and look real quick. Oh my god, my VPN's freaking out. Okay. Motorcycle. Yes, that's a motorcycle. Oh, it's what's his name? Cool. Casey. Wait, let me look at the code though really quick. Or does he have source code for this? Let me take a look. Once you know CPU address mapping, powerful page mapping. Hey, well, I'll take it. I'll take a look. let me save this one too. I'll take a look a little bit later. It would fit in physical RAM and use any reasonable size subset of it. Okay. For sure. All right, yeah, I'll go ahead and modify this a bit. So, yeah, instead of this, we're going to take in like a buffer. Do I need to take in? I don't think I need to take in a size, right? Because I already know what. No, wait, no, I do take in a size to initialize it. I don't know what I'm talking about. All right, so we do init. This, of course, is a C style, right? So you have to pass in every object. But yeah, we just pass in the backing buffer as a, data, and then pass in the length, and then just assign the buffer, assign the length, and then reset the offsets. Yeah, it's simple enough. All right, let's go ahead and do that. So we'll call int or init, and then we'll do t pointer backing buffer, and then we'll say size t. Buffer size. That is a bot. Bye bye bot. All right. Okay, and let's do as they say. So we'll say the backing buffer is m buffer. Sure. M buffer size is equal to buffer size, and then m offset is equal to 0. Simple as that, right? Okay, and I'll just get rid of this for now. Yeah. Should I, I'm trying to think, should I make that function like a static function? Does that make sense? The one that calls the, like getting the memory? The ones you guys were talking about? I mean, that makes sense, right? Like, you could call it at any point. I want to use that now. I'm gonna take a look at it. Oh, it's 4K aligned. Oh, sick. Right, so I mean, presumably I have to write a wrapper on top of it for Linux and Windows. But I would just, call each one for each platform. But yeah, we have a address. The naming schemes for Windows always kind of hurts me. Like, I get that it's a convention, but I guess I just need to get more used to it. LP address, optional, yeah. Yeah, it just returns the actual pointer. So you just do the size, location type, and the protected, okay. Is there an example down here? Yeah, return value. The return value is the base address of the allocated region. Does this one guarantee the same thing? Right, if def, yeah. I'm just wondering, I don't know, I'm trying to figure out where I want to put this function. I'm gonna put it up here. Let's make a separate file, make a header, and then we'll call this system allocate. I guess. Does that make sense? Okay, so they're both 4K aligned. That's cool. Yeah, 4K aligned. Hell yeah. Sys allocate. System allocate. I could rename it, I guess. System allocate. Okay, and then we'll make a inline function, I guess. Returns a, let's see. Keep my stuff consistent. So we'll do CS. No. Okay, cstd int. Yeah. Program. I feel like I know something and then I go into something and then I start working on something else or working on something new and I just realize I don't know anything. Oh man. Guess that's just life, right? Wait, inline. Yeah, yeah, right. There's so many details, right? And you're just kind of sitting on top of it. I feel that. I really feel that. Allocate. I suck with naming. I'll just say allocate right now. Or also, I'm forgetting to use my namespaces. let's do my namespaces. So namespace Cargano memory. Oh, who's OS dev? You got me curious. Oh. Nazem, Yazem. Oh wait, I clicked ARM. Memory management, segmentation, paging, memory allocation. Oh, this is nice. Oh, for sure. I mean, still, this is like useful to have. I think I might put this in my learning resources. Video links, coding links. I'm putting coding tools for now. Does that really apply? I don't know. I mean, it's cool to look. It's cool to look through, though. Yeah, you're writing in the whole kernel. Yeah, this is fun. Paging. Hey, yo, Pedri. It's nice to see you. Yeah, it's been a minute, hasn't it? No, I'm enjoying this because I don't know a lot about this field, so like I'll take what I can get, you know. I would have known. I would have just been using Malik, you know, before, but no, if it's better. Assembly. I don't think we're getting that far, Pedri. But I like the energy. No, I'm just looking through this wiki real quick. It's just like OS, like designing OS stuff and whatnot. Pretty informative though. I think I might take a look a little bit later. Yeah, no, I don't know if you can see the conversation before this, but what's up? And sorry if I don't know how to say your name, but I'm gonna say Emblin. I'm gonna shorten it to Emblin. Has been telling me about like what was it? I guess for like Linux and like POSIX, or what is the word? I forget the name for those types of the systems that implement that or whatever. But they have mmap, and then on Windows you can use virtual alloc, and it gives you like better alignment. It's defaulted 0, and it gives you a lot more options too. I'm gonna look into that so I can maybe add some better allocation. Unix, there we go. Yeah, I don't know why I couldn't think of the name. I'm gonna go with Emblin. Emblin, sure. But yeah. You probably see the title, Petri. But yeah, I'm just doing writing my own little linear allocator right now. I'm just gonna call this allocate. For now, I'm gonna go ahead and just do. I'm just going to do malloc, but I am gonna put a note to come back and really go with this. I just want to make sure this works first before I start adding everything at once. So let's see, CSD int. Oh, but yeah, this is the linear allocator. I'm just putting up the API right now. It's pretty much done. The only thing left is just to implement allocator, which, oh no, I mean, this is pretty much done actually. Oh, okay. Oh, it is. Okay. Right, you just get better alignment for virtual alloc. Yeah, 4K, geez. This one, I guess it's an inline. If it's inline, I have to define the whole thing here. I could just... Like, I want to make this just like a globally accessible function. So... I'm used to writing classes. I can't remember the names for when it's just a function by itself. Inline... Because I kind of want to have this be in an implementation file, if possible. So I don't have to add a bunch of includes. For sure. I'll be here, Petri. Via aligned listings ignored mm value used, right? Okay, so you have to specify if you want better alignment for that one, but if not, they just give you minimum. That makes sense. I think it's Niadoki, Pedri. Mister with the multiple accounts. I see you. Okay, so allocate will just give a size, so we'll just do size t, data size, and then we'll just return. What is it? My brain now. I don't want to make it a global thing. You know what? I'm overthinking it. Whatever. Let's just do. Where was it? This one. Sure. Oh, why not? Also, get rid of this free. We don't need this anymore. Return include CSD. Yeah, exactly. So you said I should use aligned alloc. Is that one in lib? Or maybe name it aligned alloc. Or wait. I'm just confused. Hold on, let me go check. Yeah, where is this defined? CSDD. Oh, it is there. Okay. So you specify the alignment and the size. Bytes of uninitialized memory, which alignment is specified by alignment. Size must be an integral type. Let's say if it behaves as though it's memory. This is in the C library, huh? Oh, yeah, there it is. Nice. Malloc, alloc, realloc, free. Okay, and the free just applies like wherever, right? Oh wait, free sized aligned alloc. Free aligned size. Wait, what? Word? Slide. Let's go. I'm gonna read this over here for a second. Let's see. Hexes assert. Oh wait, you say it was in helper cell line given values to an arbitrary value of 2. Let's see. Wait, let me just search for aligned size. Wait, what was it called again? Aligned alloc. Okay, so this is just for the arena. Like, of course, it's doing the... yeah. I think I saw something similar for the... like, this alignment is for... the actual, like, final allocation from the arena, right? Specifically. I think I saw them talking about that, too. But we're trying to align just the beginning allocation, right? We'll do both, but at the moment, we're working on the initial allocation. It is in here. Line 119, internal memory, init memory, struct arena, platform capacity, render arena, renderer capacity. A lot of stuff. Okay, so let me pull this over here real quick. Of using virtual alloc to get what you need. Okay. Let's see. Starfield. They making a Starfield? Oh yeah. Okay, debug stuff, sure. You said virtual alloc. Okay, so we got it right here. All right. So alloc type, mem reserve, mem commit. Those are the alloc type. Let me pass that in along with this, I suppose. Okay. Okay, and then you get the pointer back. If not pointer... Wait, what? oh, if like it fails, then you try this, and if it still fails, just return false, and then we handle it. Let the memory return by alloc is 0, so no need to memset it. Oh, nice. Then we got the pointer, platform capacity, and length 0, renderer arena, and starfield arena. Okay, okay, I think I get it. So they're doing a bunch of arenas here, sure, in like one big go. Sure. So they alloc like one big space, and then the alloc pass to this point so they can get this pointer. Okay, yeah, I got you. Oh, I got you. Not usable, not trademarkable anymore. Was it like a Starfield simulation though? That's sick though. I got you. But again, this virtual alloc, right? So Windows only, right? But and then you had these options. Okay, so base address. What's up with this base address? Let me read the docs too for this. Make sure I understand what's going on. So we're ready to go. Virtual alloc. I want to make sure I understand these options as well. LP address. End goal was a Space Engineers clone, but I have done nothing on it in ages. There is an equivalent Linux platform C if you want mmap version. Oh, okay, okay, I got you. Well, I mean, you know now, right? No, but that's sick though. So no plans on like working on it more? The region to allocate. The memory is being reserved. The specified address is random. Also determines where to allocate the region. Depends down multiple of allocation granularity. If the memory is already reserved and is being committed, the address is round down to the next page boundary. Is being reserved, specified. Okay, so the first bit is optional. So what is the point of I mean, I'm kind of reading it, but I don't really get it. I mean, I get that you could just pass null and call it a day, right? And it just, the system determines it. But yeah, this pointer, this first address pointer, is already reserved and is being committed. The address is rounded down to the next page boundary. Like, it tells it where it should allocate it? Is that what I'm getting from this? Like, it's like, okay, this is where you should try to allocate it? Oh, okay. This is within enclave that you initialize and the version fails. Okay, let's see. Reserves, commits, or changes the state of a region of pages in virtual memory space of the calling process. Region. This function is automatically initialized 0. Yeah, I get that. To allocate memory space of the process, use. Okay. Okay, so I mean, I can just assume this is null for now, right? Wait, where did your thing go? I'm losing this. Oh, I pulled it over here. Okay. Let's not do that. Let's bring this over here, yeah? There we go. Okay. Okay, and here you did void pointer TIB. What's TIB? Allows you to map memory at an address, as you say, but that is only used for debug. We'll always use the same memory location when we're loaded. Oh, okay, so like you can reliably know where to put it. Okay. Like when you're trying to debug it, that makes sense, yeah. But otherwise, you'd want it to just specify itself. So I guess if I was really having issues, I can come back and add this as an option. Okay. For the grid data, some funny indexing that to allow the allocated memory be accessed with X and Y and yada yada. Right. Yeah, I feel like that still counts. Definitely. Yeah, it's still an arena. Yeah, this is just like we're getting more into like the details of the initial allocation. But yeah, he was saying before too, like you can do all this alignments, so like some of this alignment stuff with the malloc, but it just defaults to like, what was it? You said 16 bits, or was it 16 byte alignment? I didn't. I just saw 16. 16 byte makes sense. Okay. All right. Well, yeah, I'll default this null to null. Yeah. The next thing is we want the size, which is just the size. Sure. You know, the region size of the memory. If this was rounded up to next boundary. Okay. Cool. Allocation type. So this is what I wanted to read. Make sure I knew what I was doing with this. You can also specify the following values as indicated. Physical, top down, right. I'm gonna take a look at the ones you used as well. And yeah, it just gets the base address, and then you go from there, right? As an associated page states, form the following. So again, with this one, like, preferably you would do it once at the beginning of the program. Or could I just use this? Because this tries to get like a full page alignment, right? Like, could I use this just like a malloc, where I just kind of just do malloc and like I just call this and then go about my day? Because again, you said malloc is a wrapper on top of this, right? I use different rules in different memory regions for different objects. Use one memory region for small objects. Right. So like malloc is kind of set up in a way where it handles itself for the most part. But ideally, the memory places here. Nah, yeah, I'm definitely in trouble. Yeah, we're just setting it up right now. The basic linear allocator. We're just looking into like malloc and like virtual alloc to like get the base memory first. Okay, but yeah, you said ideally you would do like a big allocation for virtual alloc. And then you would go from there, right? Malloc would be more like throughout the program, smaller bits, it handles itself, or has better processing for that type of thing. Yeah, general purpose, yeah. Nothing but the lifetime memory, and you're just trying to like get something out there, yeah. Memalloc. Nah, I don't know what that is. I'm curious though. So many, right? Yeah. I feel you, Doki. I'm with you. Optimize general purpose allocator. Oh, it's a Microsoft. Okay. Oh, I got you. I got you. Yeah, I'll take a look. This general purpose allocator with excellent performance. I am going to write in the first one though. The one we were just talking about. Yeah, again, this one is more for like, again, general purpose allocator, right? Kind of like Malloc, but it's more optimized, like you said. But for my use case where I'm just setting up arenas, it makes more sense to do like a big allocation at the beginning and then just move on from there. Oh, that's a lot of features though. I might look into it. Yeah, like because the arena, like the whole point of the arena is right. Is like we set it up ourselves, and then we know when the boundaries fail, and we can deal with it. Let's see. And then you know what your use case is, so you can optimize for that. Malloc, you just throw things at it and call it a day. But yeah, I'm trying to get away from doing that. I will take a look though. I mean, a little bit later. I got a lot of reading resources to look through later. Not bad. Okay, I'm gonna read through this real quick. Let's see. So, type of memory allocation. This parameter must contain, yeah, it's a bit field or whatever. So, allocate memory changes. Function only guarantees that when the caller later initializes the memory, it comes to 0. Reserves the ranges of without allocating the range of the process's virtual space without allocating any actual physical storage. Indicates that data in the memory range. Okay. The pages should not be read from written to the page file, however. Okay. On the address range to which memset, okay. Large pages, physical, top-down, right, large. Okay. Okay. I'm gonna get a little more into that in a second. And protection region. And then that's it. Okay, so what did you specify in yours? Let me see. So you put page read write, that makes sense. And then alloc type, which you have set as mem reserve commit. Okay, that was that thing you saw. And then mem large pages. So let me really look at those. So you were looking at mem large pages and then this bit, right? Reserve commit and then read write. Large pages allocates memory using large page support. The size limit must be a multiple of large page minimum. To obtain this value, use the get large page minimum function. Oh, okay. So it has to be, okay, that's interesting. Yeah, so it has to be that. I mean, ideally that would be the case, right? If you're doing a giant allocation at the beginning, so that makes sense. And then the other two you had was at the top with that OR statement right here. So allocates memory region. So these are options, like mutually exclusive. So you either commit, reserve, reset, or undo. Which is you can set up your own pools. Oh wait, I think I got lost in that thing. Wait, let me go back up. Does less work now. While maintaining my finer control over the backing memory for the pools. Yeah, and then I also want to do again those visualizations for like my memory inside of my engine. So I will be taking advantage of those pools, yeah. Huge pages for larger pools and avoid trashing your TLB with many 4K pages. Using 2 as appropriate. Equivalent. Let's see. Transparent huge pages allows the Linux kernel to automatically upgrade large mappings from 4K to 2 megs if the alignment is correct and the mapping spans multiple 2M pages. Large pages has some caveats, IRC. Transparent equivalent. Okay. While maintaining finer control of the backing memory of the pools. Let's see. Fallback path without the large page flag. I forget about. Okay. Right, this is the allocator. Oh yeah. Establish large page memory regions, which is particularly useful on 64-bit Windows. Each signal. Oh, you need a privilege, okay. And I saw that function get large page minimum, yeah. And then include large pages when you call virtual alloc size, and that must be multiple of the large page minimum. Yeah, okay. Regions that use large page memory keep the following considerations in mind. Large page memory region may be difficult to obtain. For long because it must be contiguous. Yeah, if it's fragmented, then you have a lot of issues, right? Makes sense. Memory is always read and write and non-pageable. Okay. Let's see. So that was for that case. I got you. And you specified large pages. Okay, and then of course you can do this because you know what size you're doing immediately, right? It's going to be a large allocation. Where's this len come in? Oh, yeah, yeah. So you're doing the capacities added together. And then huge page alignment. Oh, yeah, yeah. Okay, so large page minimum. And then huge page alignment. What's the line next? What is that? Is that defined here? Okay, that's like a... Okay. It's like a Windows thing, sure. Or maybe that's one of your functions, I don't know. Platform capacity. I'm learning so much, I'm like trying to process. Like there's an appropriate meme to put here. Okay, if I just want to do like a smaller, because I mean ideally you would do this with like a bigger page size, right? And you already know in your case that you are doing that because of this. But smaller allocations, I could just use malloc, or like gentleman said, what was it? Use how do I say? Memmalloc, that'd be cool too. Yeah. Right. Yeah. And then you could do either one, yeah. Okay, I think I get where I'm at now. So then, like for this case, right, you're doing all this, and then this would be good for like a large allocation. So realistically, I would use this for the large allocation. So that would be that use case. Otherwise, I could just do a normal malloc. So maybe I could split the functions into those two. I'll have one that's just normal malloc, and then I could just use that in certain cases. And then once I know what my requirements are and what large pages that I want to use, then I can switch over to getting more deep with this. Oh, okay, but does the malloc call preserve that like 4K alignment you were talking about that you get from the virtual alloc? That's still different, right? Or at large sizes does it not matter? Mem large pages. Fits in the same size, same virtual alloc. You might get 4K alignment, but you're not guaranteed, and you might want that. Yeah. In that case. So that would be the case where you would really want to use virtual alloc. Which honestly, if we are doing this, I mean, the ideal case would be that you would allocate everything up front at the beginning of the application, and you would know your boundaries. And then from there, you would just subdivide that buffer as needed, right? Yeah. So just for the use case, that makes sense. Yeah. Okay. So here's what I'm gonna do for this situation. I'm gonna save this too, because I'm gonna reference this later. Thanks for the link, by the way. I hope you return to the project at some point. That's cool. Okay. For now, I'm gonna go ahead and just use malloc, right? To keep it simple. So, but to do look into virtual, because right now I'm just testing the basic linear allocator, right? So I'll just use malloc for now. And then once I'm starting to do like bigger sizes, I'll look into virtual alloc and mmap for bigger allocations. Or you know what? I'll put this here, and then I'll also maybe make like a little to-do list so I don't forget. I'm not gonna do it now, but I'll come back to it. Handle bigger options with... Wait, what's it called in? Yeah, virtual alloc and mmap. I'm cleaning some of these tabs out in a second too. It's getting messy. Virtual alloc and mmap. Current allocations use current system allocations use malloc. Might want to switch over to virtual alloc and mmap. For larger allocations. Sublime blind toe stubbers, everything is let's see, funny thing that blew my mind. Didn't realize really gives me FPS. I drew them on top of each other like it was one and scaled the overdrawn triangle to the size of the screen. So I really put the frame rate back to 2.5K, probably the most extreme extent learning lesson. I feel it though. I don't think I've done that before, but I feel it. Oh yeah, no, I mean, I think before I was doing like 5 streams a week, and I was like trying to get everything done on stream. Back then I was kind of rushing through everything, but nowadays I do it once a week, and I do most of my coding off stream. So I'm not really that worried to be honest. This is more like a chill develop, and I usually just talk about where I'm at the beginning of the stream. So no, don't feel bad. Let's see. All right, let's do malloc. Malloc size. So we'll do data size, and we'll do what is that one? Unreferenced parameter. Wow, I did not type that correctly. Unreferenced. Do I have to include something for that? I guess I could just do this, so whatever. Yeah, maybe I'll just switch to doing this. I mean, most people know what this means, right? So we are not using alignment. Oh wait, oh you said use the you know what? Okay, I might as well just use it, right? The aligned variant, right? Actually over allocate and then align the return pointer. Oh, okay. Wait, what about using what is that one? Aligned alloc. Can I just use this? And call it a day? Oh, you wouldn't? Wait, what's the reason? This one's not good? uint pointer raw pointer is equal to uint pointer t malloc plus alignment. Oh yeah, yeah. You over allocate with the size plus like the max size of the alignment, and then you just call the align next, which I'm assuming is already defined in there, and then return that. Have alignment limits, and it may not work on window. Oh, okay. Oh, I got you. Okay. Yeah, sure. All right. Return does not. Oh yeah, yeah. I know. Okay, let's put that in. Let's see. So uint pointer, unsigned int pointer. Yeah. So return pointer. Return first time I've ever used uint pointer underscore t as well. I think I used it. I was learning from what's his name, Jacob Sorbier. He was using it, but yeah, not really used to the whole C thing. All right, so then we can use the alignment. Malloc. Return align next. And then again, we over allocate. So we do the data size, sure. Plus the alignment, makes sense. And then align next. Okay, and then you implement this yourself, right? Oh, the definitions. Align. Wait, did I read it wrong? From my first link. Let's see. I might read that too, just so I know how that works. So not this one, but the other one. Let me scroll up. Let's see. Okay, I see it. And then align next. Okay, so you define it as this. Say both. This power 2 is aligned. Okay. I'm gonna read this through to make sure I get it too. And use a hash there for that. Let me take a look. V and align. So this evaluates to align prev, which okay, gotta get the prev one too. Let's see. Oh wait, let me scroll all the way down. Compile time asserts. They do have like something for that. Yeah. Static asserts. Yeah, const expert. I might. Let's see. I'm just trying to see how you used it. So you said align next, and then you did the raw pointer. Return pointer. Why did I do it like that? Return pointer. And then the alignment. Let me, I'm gonna expand this in line. Okay. So, let me expand these separately. So this one takes in, okay, this one takes the same arguments. Let's do align previous. And then we're gonna go ahead and expand this. Okay. alignment -1. Okay. So alignment. Okay. And then we negate it. And we do an AND operation. So check if with the return pointer. And then from there. Okay. Okay. I think I might be able to. Let me see. Alignment. What's up with the alignment -1? Like I understand these bitwise operations, but I don't know what the -1 does to it. It just. I mean, well, it just subtracts 1 from it. Yeah. Okay. So size to if you have an alignment of, it brings it down to. Wait, never know. I get it. Brings down 1, and then the not. Flips it, and the AND with the return pointer. Okay. Right. Well, the main thing is the main operation of this is that we provide the return pointer, provide the alignment, and then this gets modified so that this is now aligned, right? So it brings it forward a certain amount until it's on the next alignment, because of course this one aligns it, or this over allocates, so there might be some leftover, right? And then you're basically moving this pointer forward. And then the bottom portion of it that you move forward from just isn't used, right? That's like the overall usage of it. Or I mean, that's what this does, right? Essentially, it moves it forward, and then that first bit is just not used. So that would be the input and the output. So then alignment previous. Okay, and then you align this plus this. Okay, so that's the complement. Yeah, I might need to look at the bits later, but you know what? It's okay. I'll come back and get it. I understand what it's doing at the very least. And this returns a, what does it return? Does not match the function type? Yeah, because you're using this one, right? So I'll just cast it to a uint8_t pointer and call it a day. There you go. Toast over that. I'll see have no clue to why. What's going on? Shader storage buffer objects. Shader storage buffer objects. That sounds vaguely familiar, but I haven't worked with that in a while. Wait, where's my thing? Oh yeah, okay, no, yeah, I use these. Yeah, I get you. This is how I do my my batch rendering actually. I didn't know it was called that though. Okay, cool. You unable to use storage that contains 3 32-bit floats representing a vec3 leg. Yeah, it's not understanding what was going on. But when I changed the buffer to a string. Oh yeah. Yeah, I don't know, man. How are using use 3 was it yeah, use the incorrect type and then it works for some reason. Yeah, it's weird. I don't know. That is a toe stubber. And to guarantee that our line never goes behind, we must Oh, what the heck? Yeah, the Adokia, I don't know. I don't know, man. I mean, it works. I mean, did you eventually figure it out? I've been so far out of graphics programming for a while, so I get the terms, but then like the actual details evade me. So call my toe stubbed. All right. Well, anyways, this should work. We got an allocation function working, so that's cool. And it should be aligned to this amount. Let me read that page I was reading. And let me clean out some of these as well. Connection to server. I want to read the section they were talking about with alignment, so I get it. Okay. The amount of bytes that someone to the power of 2, blah blah blah. This music. Yeah. Oh, okay, so this is just power of 2 alignment. Is simple modulo arithmetic. Is power of 2. Update our original to support align properly and store the data within the structure. And you call it within. Okay, sure. Okay, yeah. I'll get to this in a second. So what I want to do now is just go ahead and test the current linear allocator. Make sure it works, and then we'll go from there. So yeah, here I should be able to allocate. That's cool. We can go ahead and include that as needed. Yeah, this should work. The allocator should work. Let me double check this to make sure. Like 3's but 4, huh? Yeah, I don't know. I hope you figured out Nidoki. And let me know how you fixed it, because I don't know. Okay, and then this returns 0. Should I memset it? I kinda don't care, to be honest. Just return it. Again, and I think I remember you saying that before, Emblick, that the actual caller should define how it wants to use the memory. I mean, mem setting it to 0 is nice, but we really should already have a way of dealing with that from the user side. So I'm not going to bother with this. I did do this, right? I didn't. Okay. Buffer size. Buffer size doesn't change, so plus equals data size. Just take this and move up. We don't need all the extra details, right? Yeah, that should be good. All right, you guys go ahead and try it. I'm gonna go to my little testing section and try it out. Right. Yeah. I think they were detailing how to add that here. To go ahead and add the alignment to it. Default alignment. Oh. Yeah. I'll go ahead and add this. But let me go ahead and test it real quick, and then we'll go from there. Make sure I didn't break anything silly. Where did I put this one? Where did I put it? I'm trying to find my test code. Alright, I have like this random panel of like test code that I use. Where did I put it? So this is basically just garbage code, so don't let's see. Yeah, so here's my little test area. It's its own little section. This one is like a general like harness. So I have a bunch of like debug values that I can like hook into in the engine, and then just try out values or whatever. And then my little area where I just random code is over here. And I like it over here because then I can do a bunch of like UI stuff with it. So, and this one is garbage. So yeah, don't mind the messiness. Yeah, I've been on like a organization kick, so hopefully soon I will be restructuring the engine. Currently, it's a lot of singletons, a lot of not a lot of architecture with these things. Yeah, it's just not working for the new use cases I want, and then like some of the things I want to do with it. So I'm gonna start moving towards like bigger dependency trees and trying to like I don't know, everything's so tightly coupled. It's kind of killing me. Yeah, that's true. But I think I do like. Yeah, I mean that's fair. There is a lot of things that will be globally available, but I still want to manage some of the coupling myself. Yeah, because at this point it's like I'd be calling like audio code and like. I don't know. It's a mess. I'm kind of like under the opinion that I'm gonna use my networking code that I just wrote as a chance to test out some new code structure and design. And then if I like that, then I'm going to move it to the rest of the code base. But I want to do it on a smaller scale first. All right, let's see. So I do have an init function. Let's do that. We'll just throw it up top here as a static, because whatever. Let's include the memory one. No, I want to do it. Linear alloc. Also, I don't have this under the right namespace, do I? That's not cool. Cargano. Oh yeah, and then Mbleck, you said your code. So what I saw that you do the star field. Do you have a GitHub that you use? I'd love to take a look later. Oh, for sure. I mean, I figure I'd just ask because I was curious. But I respect if it's not like affiliate. Okay. Where is my... Let's see. I think I have like an examples one I put. Okay. Yeah, I might take a look through it later. No. I mean, I'll find the gems. You know what I mean? I can't say much. My code's a mess, so. What happened? Oh yeah, these aren't defined anymore. So we'll do namespace Cargano memory. And take all these and put it in the namespace. There we go. That should solve that. Alright. Alright, how do I want to do this? What do I want to allocate? Let's allocate some random struct and then try to like print out its values, yeah? And maybe let's make it overflow. So let's go ahead and build the linear allocator first, and then we'll go from there. So where's that testing section? So we'll linear allocator, and then we're going to do static Cargano memory linear alloc. S random alloc. Sure. All right, and then of course the... Wait, why is everything here? I don't think I need to do this. I'll just get rid of this, please. There we go. Take this, put it in panels. There we go. All right, random alloc. So now let's go ahead and allocate some stuff. Yeah, let's define a struct real quick. I'm just trying to think of the example code. So we'll do struct, test struct, and we'll put some stuff in here. We'll put let's put it up here because I don't want to be defining Cargano everywhere. Let's do fixed string 32. Test string, and then a float val. Let's see, I think the text repo might be more useful. It has code, and also the website repo. What's up with the serve repo? Test struct. Okay. What do I want to test with this? We allocate a few objects. And then let's just free everything. And then start over. Okay, let's try that. So what we'll do is, this is basically the init function. So we'll do some stuff right here. Actually, I'm surprised I'm not. Oh, wait, no, this is, okay, no, this is the init function, my bad. A lot of random garbage in here. I was doing some spline stuff too. That was kind of fun. Okay, so S test out. S random alloc. Okay, let's go ahead and allocate it. So we'll say S random alloc. Oh, we want to include the other one too then. Cargano memory system allocate. That's alloc. Backing buffer. Okay, so then we want to go ahead and do memory allocate. Let's say data size, like, I don't know, how many of those, how big is this? It might have some alignment issues too. So this thing is 48 bytes with 8 bytes of alignment. So this small HTTP server from scratch with an object pool specifically. Let me double check. Yeah, it uses an object pool with intrusive free list. Oh, use a free list with the object pool. Okay, that's cool. I think I saw someone using that too recently. So 0 additional allocations, inefficient via the linked list. Yeah, because the linked list keeps the, I saw that, like the linked list keeps the state of all the freed, right? And then when you deallocate, you push to the free list, and then when you allocate, you go to the free list first, and then after that, you if the free list is empty, you just move the pointer forward. Yeah. Isn't exactly how I do it. I would structure the linked list slightly differently, but it does work and still makes some sense. Okay, well, I'll take a look. Sure. Okay, yeah, this one is 48 bytes. So let's do like a multiple of this. Let's do like 3 of them. So what was that? 120 plus 24, 148. Alignment is alignment data. So when you're doing like alignment, what do you usually go for? Or like what makes sense in what scenario, you think, M Black? Also, sorry if I'm using you as like like my like memory resource teacher, but alignment of T. Oh. I feel it. You're talking about the first file, right? Let me see. Maybe it was the other one. Let's see. A line of T. Okay. Let me try a line of. Let me try that. Let's see. And the type is the test struct. Test struct. I'm used to using size of, a line of. Let's take a look. Turns the alignment is required by instance of a type, indicated by type ID, which is either complete object type, an array type. Turns the alignment of the reference type. If the type is an array type, alignment required is. Okay. A line of empty, line of 1, 2, 4, 16, 1. Yeah, this is what I'm trying to ask. What is... Like, I get that they're different, but... Would it be the same as, because I know it pops up as, it kind of tells you in this little linting thing that the size is 48 and the alignment is 8 bytes, right? Just memory layout, let's see. Oh. Strictly aligned member. Okay. Yeah, so if you have... Yeah, you know, let me try to mess with it. Let me see. So let's do something like that. That'll mess stuff up. Let's do like fixed string 64. String A. And let's throw in a bool here. Bool val 2. Or some, I don't know. So alignment's still 8 bytes. Oh, but now we're doing SIMD in that case. Right, and then you could pack stuff if you were doing that. I want to get into SIMD at some point. So it seems like it's capping out at 8, right? What if I do... Actually, let me... How is... You said strictest, but let me see. How is alignment calculated? How is struct alignment calculated? Is the way data is arranged and accessed in computer memory consists of 3 separate related issues: data alignment, data structure padding, and packing. Performs read and writes to memory most efficiently when data is naturally aligned. I mean, yeah, that makes sense. Bytes. Yeah, like you might have different words for different things. I get that. Like to align as for performance reasons, to align structures to cache lines and thus avoid false sharing between structures. Yeah, well, yeah, I get that. So 64, align as 64. Where would you use that? Let me take a look. Align as. Let me see the usage of that. Expression, type ID. Okay, so you can do like one of these, sure. Maybe applied to the declaration definition of a class. Oh, you apply it to their declaration of a non-bit field class data member. But this is assuming like 64-bit architecture, right? So it could fit into those cache lines. The object or the type declared by such a declaration will have the alignment requirement to the strictest. Okay, yeah, okay, strictest largest non-zero expression. Yeah, so that would be, if you were doing different architectures, you'd worry about that. Like realistically not, right? Yeah. And also, I'm mainly going to be targeting desktop for now. I don't really have any intentions of doing console. But even then, I still use 64-bit for the most part, right? Except for like certain exceptions. It's really like, I don't even know. I can't say I know which ones specifically use 32-bit or some other random value. Or just other value. The strictest largest alliance on declaration is weaker than alignment. It would be alignment. Yeah, I think I saw that too, PowerPC. I think I saw someone mention that. Do people use PowerPC? Oh, okay. Reduce instructions set computer. Yeah, okay, yeah. I got you. Yeah, it's fine. Okay. Well, anyways, I was just curious. Wait, this one calculates it as this, and then we can do... Okay, well, let me see the usage of align as, though. So if I did this, let's find align as. Is it telling me to take a break? Let me see. Oh yeah, okay, I'll take a break. I'm gonna stretch my fingers. Hey, MCH. Thanks for dropping by. Appreciate you. Just doing some memory stuff, so you know how it be. I'm learning a lot. This is nice. This next week when I'm off stream, I'm gonna be reading a lot, so that'll be fun. Oh, okay. Okay. Fingers are feeling better. Let's see. Yeah. Switching the line as in here is probably not the best thing. Struct align as 3. Oh, you put it before. Right here. And then it'll do that. Okay, sure. Well, that's if you know like what you want from it. Otherwise, I could just put in the align of and go from there. I'm just thinking to myself real quick. Okay. Which one's missing a definition? Let's see. Init. What is it? So allocate takes in 2 arguments. This init takes in 2 arguments. Buffer size, right? 148. Okay. So magic numbers. Float, buffer, float. What am I doing? Size t, buffer size is 148. Or even better, we could just do size of what is that type? Test struct times 3. There we go. Which is okay, sure. Buffer size. Okay. And then alignment is a line of test struct. A. Okay. So we initialize the buffer, right? Allocate the stuff from that static call. Should probably qualify this a bit more so we know what's going on. Maybe change his name too. I'll do that a little bit later. All right, so we initialize it. Wait, is it? Oh, you're talking about like it's just size of 3? Oh, okay, you scared me. I was like, wait, is it? Oh, I got you. S random alloc. Is it getting late over there? Let's see. We init with that. Let's try to make 3 of these. So we'll say, should we do a pointer? That makes sense. The stack allocated is that this one we get the memory from it. Yeah, so normally the idiom is you do test struct. If we're just doing malloc, right? So test struct pointer test struct a is equal to, you do like new, and then you would do test struct, right? I'm just reminding myself how this works. I haven't done memory allocations in like a manual new stuff in a long time. Okay. Otherwise, if you're doing malloc, then you do malloc and then size. What was this one? Size of. What is that? Test struct, right? You get memory back, and then test struct pointer. Test struct pointer. If you did malloc, something like that. If I'm, again, I've never used malloc before like that, so I don't know. But now we have our little allocator, right? So we're going to do some allocations with that. So now we're going to say test struct. I guess I just duplicate it again. But this time, we're going to do this. We're going to do s random alloc. And then here we're just specifying data size. So we're going to say size of test struct. Okay. And we get back this, which we can just convert into a test struct pointer. Okay. Placement new exists. New pointer. Oh, okay. Okay, wait, so if we do this, now we have that, and then let's just write to this. Let's do test. Let's try this. Test struct A. And we'll say test string. What are these names anyways? Let's get rid of these. Okay. Test string, and that should be fine. Yeah. I think I have a C string overload, so this, I mean, I better have one. This is a new here is a random string to test. Okay. And then test struct A val, right, is equal to 3.0f. Okay. Cool. All right, so now that's allocated, right? And yeah, I probably want like a corresponding free for this, huh? You know what? I'm not gonna worry about that. Is that test struct will not have its constructor called. Oh yeah, huh? Yeah, it won't. Use new arena dot alloc test struct. Oh, okay, and then it can call its constructor there. Yeah, no, I get what you mean. And then the constructor just needs to be available, so that would be a nice template on top of it. Yeah, and then POD doesn't matter, yeah. Yeah, fair enough. Okay. Do I want to add those? Yeah, and also the memory that you get out of that is going to be, what is it called? Garbage memory, right? So if I were to try and access it right here, it would be very weird. Yeah, you could just template that function and call the constructor on it. That makes sense. Right. Free function helper might be useful. Yeah, the additional new, right? I don't know. Well, I might try that that template alloc though. Let's just try it. Might make this whole thing easier. Of course, now I gotta move this whole thing into the header file. Small price to pay, I guess. Yeah, because again, the other main issue is that with this current thing, we're just getting back garbage data. And this struct, especially if I defined default data for it, which I probably do, like if I do, this is a string, right? And I put a default data right here of like 3.0f, right? I might want to do this and assume that it would be here. But yeah, in this case, it's just going to return the alloc value, and it's not going to be constructed, or it's just going to be garbage data inside of it. Template type name T, size T, N. Template more usable, right? Because then you would pass along whatever constructor values you want to, or whatever values you want to like pass along to the constructor. That makes sense. Okay. Oh wait, let me bring this light up really quick. Let's see. Template type name T, size T, N. Return back a T pointer. Yep, array allocate, linear allocate. Size T is equal to size of T. Oh, that's nice, and it automatically has a size of T. I feel that. No, I mean, I get the general idea though. Return new alloc. New alloc size align T. Wait, but yeah, that usage of new though, yeah, that's what I'm wondering about. So you might want to use new. Like, I get all the template stuff and everything. I could figure that out, but the new, even that placement new is additional for you. I haven't looked into the new operator. Let me look into that. New, and like I've used it, but I've never like probed it. CPP reference. Type new initializer, because I mean, like my understanding is that when you call this new, right, it's gonna pull from the heap, right? Yeah, this is doing heap stuff. Uses the given memory and only runs the constructor. Oh, placement new uses the given memory and only runs the constructor. Oh, really? Oh, what? Placement new? I never used it like that. Placement new is a variation new operator. This new normal does two things: allocates the memory and constructs an object in the allocated memory. Yeah. Allows us to separate above two things. In placement new, we can pass a pre-allocated memory and construct an object in the. Oh, okay. That was what was confusing me, because I'm so used to the normal usage of new. Okay. Normal new heap and constructs the object. With normal new, it's not known that at what address 22 is done using delete. is required for optimizations as it is faster not to reallocate all the time. There may also be a case where it's required to construct an object sometimes. Okay, let me see how this is used. Oh, okay, so you provide the buffer pointer right here along with that, and then it'll call the constructor for that along with that buffer. Okay. Sick. Yeah, that's didn't know that. Let's see. Placement new. Use the memory. Classic new allocates memory. Placement new runs the constructor in place. Yes. Classic new. Allocate via malloc. Yeah. Classic new. Yeah. Overloading keywords despite it making no sense. Calling the constructor directly via the pointer, but I don't know. Yeah, I was confused. I always thought new just straight up was always heap allocation. So yeah, that is a bit confusing. But yeah. Gotta love the overloads in C++. Have a plus operator allocates heap memory for no reason. Gotta love it. Okay. Let me look at that example you're doing then, since now I kind of understand what you're talking about. So, template type name T. So we provide the linear allocator, the size alignment, return new with the placement, and then you call that one's constructor. Another syntactical sugar. Okay. Now I'm wondering, can I put this inside of the class, or do I have to make this as like a separate function? I always forget with template functions. Because I know the C style is to provide the allocator as the first argument. Let's see. Right, yeah. So that's why I was like, because I know certain ones, if you do it in a certain way, but it's usually like weird operator overloads where you have to do it outside of the class. But yeah, let me try it inside the class. Okay. Type name T and then size. How does that work again? Or actually, I think I've used this before, haven't I? Where have I used this before? Let me just find one of my code snippets. I think I do this in my asset system. Oh no, this is the... Oh yeah, no, these are all the managers. Jeez. Where do I use this? Oh, okay, no, I know somewhere where I use this. It's in core and then strings. There it is. Don't mind this one, it's a bit of a mess. Oh yeah, you just provide the actual value. Yeah, okay. Why did I use STD size too? Alright, but doing it more... Yeah, I mean, I agree. I don't like the operator overloads going crazy either. But they're useful in like very certain... I feel like when it's like very clear, like very, very clear what's happening, then it's fine. But it has to be one of those cases, you know? Okay. T, so return a T pointer, that makes sense. We'll do Alec. Do I want to call it that? We'll just call it out for now. And of course, we're calling it on the allocator, so I don't need to worry about all that. Size of the Oh, okay, so the n in your case is the number of objects we're allocating. So you can do it all in one bit. Because you have size t times n. So yeah, if you want to allocate like multiple of the same object all at once, I got you. So, okay, sure. Size is equal to size of t times n. Can I skip the song? I'm sorry, the lyrics are kind of like getting in my way. Okay, there we go. Alignment of t times n, size t, align is equal to a line of t, makes sense. And then I'm just gonna copy down, make sense of it. Return new, and this is the placement new, okay. And then alloc size align, and then t constructor. Okay, and then do some stuff with that, sure. Complex, I'm usually remember how it works a week after. Okay, found that to be true, which scares me. Remove those parameters because they should be directly specified in the template. Yeah, and that way the only runtimes are those to be forwarded to the constructor. Right, yeah. Okay, so t size of t. So then we can just do like the variadic arguments here and then go from there. Okay. Okay, and then we'll do the allocation right there. Maybe I should name it something different. Of course, this is the actual allocation. This returns the data, and then call the constructor on it. So, let's see. Alloc type T. I'm just trying to think of like how I want this API to like end up looking. So I'm gonna make a copy of this. And let's go ahead and comment this out for a second. So I want to keep a reference. All right, so ideally I can get rid of this and just call it alloc. And then let's do a forward. Oh, forward. Forward. All right. But yeah, ideally you're just passing in the actual constructor arguments and then forward those in. CPP reference forward args and pack. Okay, let's just see how it's used. Okay, yeah, so we do auto, and then we do an R value reference to the args, sure. And then we just forward those on to the actual constructor, sure. And we are in 20, so that's as easy as that. Okay, sure. Oh, let me see what you're saying. So template args could also take default values. So you could have template. Oh yeah, yeah, and then you don't have to like specify it. You can just provide the T, and then it should figure everything else out. I think I will do that. Okay, let me get this to work. Do I need to include anything? IO stream, not IO stream, memory. I'm assuming memory is for this. So, utility, I'm assuming, is the one. Okay. And then for this, let's go ahead and add that. What was it? Auto R value. And then dot dot dot. Is that what it was? Args. Okay. Okay. And then we just want to forward them into this, right? So let's just copy that. Right. Run it over. Sure. All right. And then let's see. Size and align. Maybe I'll name this something different, maybe. Let's see. Right, right. I mean, I guess it's fine. I still would want to call the default constructor. Like in the case where we're allocating an array, you could just do nothing, and then that will provide the default values for that default constructor. And then yeah, you are allocating everything with the same constructor value, but maybe that's what I want. Oh, but maybe that's not what I want. That's a good point. Yeah, true. You're not keep allocating or anything. You're just grabbing your memory from your little buffer. So it's pretty chill. Okay, I think I might make a separate, call this something else. I still might make this public though, so you can allocate directly. No, I mean, I get what you're saying, but I mean, I think this is fine though. I mean, my main concern is like, because the way I usually define my values for most things is, I usually have like a default constructor, and I define my values in the like this basically. Like I usually don't really have explicit constructors. Sometimes I do, but for the most part, I don't. So my main concern is just I want to make sure I have these values in here. So if I don't pass in anything, it should be fine. Okay. I wonder if I should rename this something. I don't know if I should name it something else. I mean, I definitely should because it's going to conflict. Also, should I make it public or private? If you want to just allocate data directly from here instead of specifying like an object. Alloc raw? I don't know. Okay, you know, I'm not gonna get stuck on it. Let's just call it Alloc raw. So I think it's something better. Or that's not my convention. It's, you don't want to mince conventions. Right. Let it be free. let's see. Yeah, I'm just gonna go with this for now. I like raw. And then you can provide the alignment. Size T, alignment. And then let's go ahead and define this. Yeah, I don't love this name. I'm gonna change it. I just want to get something on there so I can start typing. But for now, let's go ahead and take this out and put it over here. Because yeah, I think the names are going to conflict if I keep them the same. Right? Like, so if I do just Alec. Yeah, I think I have to specify the thing. So I'll do Alec raw. Oh yeah. And again, for now, I'm gonna ignore the alignment just for a second. I'll light it back. I'm gonna follow this. Where is it? Yeah, where is it? Yeah, I'm gonna follow this in a second. But I just want to see if it works. But yeah, I think that's good. So then the size, yeah, there's no size in alignments. Okay, so this is the number of ones we want to allocate, right? So then we're gonna do this. That's total size, right? And the alignment is a line of T, right? No. There we go. Does that make sense for multiple allocations, right? So if we do allocate new with this, we pass in the args, and then we get that back, that will allocate, that will call the constructor for every single one, right? Okay, yeah. Right, keep it one so you don't have to specify it. Just equals 1, right? Oh, fair enough, yeah. If you fancy overriding it. Number. I'm always conflicted on like what names I put for these template types. I guess I'll just put A is equal to a line of T. Yeah, I mean, yeah, that makes sense, like that name. But then sometimes when I make them names that I would also use for other things, like I get them confused, or other things as in like local variables or types. Sometimes I'm like, wait, is this a template argument or is this, what is this? Because I do that for what is it? My asset system. I have like my asset manager. This giant garbage, whatever the hell's going on here. But yeah, I have it called asset value for this template. But sometimes I feel like is it confusing? Is it not confusing? I don't know. True. Yeah, IntelliSense can just tell you. Fair enough. Use the force, Luke. Alright, so... Oh, yeah. Calling alignment twice, huh? A. There we go. Yeah. Let's do count. Why not? These aren't renames. Maybe I should have looked at that before I did that. What are you doing? Why is it taking so long? It's finding every single instance of n ever created. Okay, thank God I didn't confirm it. I mean, it would have been fine, but let's just do this, please. Jeez. Right, change the. I got. It's gonna be a crazy diff. Crazy commit size. Jeez. I might just do type as well. Might as well keep it consistent, right? I know T's the norm one, but meh. Is I move Alec raw into another line? Oh, yeah, I got you. Yeah. Something like this. And then this can get picked up by the debugger. Yeah, no, I feel that. I do not love this name, man. Yeah, we're gonna figure that out. Oh, in the new. Oh, okay. So you're talking about separate those two out. Does the debugger pick that up if they're on, if I just space them out? I always thought this whole line, if it's an expression, it'll get picked up once. Oh, okay. Yeah, does it? Well, okay, you know what, let's, I'll put the debugger here in a second. Maybe I can, see if it does work. Yeah, I think it just uses the entire expression. I think. I'm trying to remember. I don't know. Trying to see if I forgot anything. I think it's fine. Type size of times count. So I do want to test this. Okay, let's try it out. Let's also move this over a bit. Unmanaged bytes. Not unmanaged. What's the term for this? Processed? I don't know. I'll just say unmanaged for now. This one, type, I guess. All right, sure. Well, let's get out of here. Just take me to where the test code was. All right, so now let's try something a little different. So instead of, we still get the buffer, yeah. We get test struct dot alloc, sure. Okay, so s random alloc dot alloc, and then we'll do the type of test structs. It's assumed one type or one value, and is assumed alignment of whatever the alignment is, and then we don't pass anything in. Yeah, that's pretty clean. I like that. One byte aligned uninitialized buffer of the given size kind of type. Oh well, the alignment thing I'll deal with in a moment. Hopefully by the end of today I'll have some proper. But that was the term I was thinking of. Uninitialized. Oh, if I had a just like a general allocator. Ayo, lovey dub. Yep, we doing the allocators. Slowly but surely. I'm learning a lot too, so just kind of going through it, but we're just doing a basic linear allocator right now. I'm gonna step through a bunch of other ones later. Oh, right. Yeah, fair. Oh, shoot me a link. I'll take a look. Just to remember. Oh, it's a CPP con, okay. It is necessary to remember it is fine for generic buffers, but casting such a buffer to a uint is up as technically untimed behavior because of alignment of int is greater than alignment of uint 8t. Right. It's fine for generic buffers. A line of int. Oh, that's interesting. Okay, wait, I'm gonna come back to that sentence because I think I need to process that. If the alignment is greater than casting is undefined behavior. It's interesting. Wait, I'll just copy it in. Let's see. I feel like... Have I seen this one? Have I seen this one? Let's see. I'm gonna save this. I'm gonna save this link so I can take a look later. But this is not my IP. Don't dox me. It's actually not my IP though. So. Good old VPN. I'm gonna skim through it a little bit though. I don't want it to. I am gonna watch it on the side though. I don't want to get what is the word? Someone being like, "You'll steal my video." I think I have seen like at least one or two CPP cons of people talking about SD allocator. But yeah, I never fully got it though. I think I am going to continue with this current custom allocator. Like I am going to write it myself because I do want to know how to write one. But I might take a look through this and kind of see how it works. Because yeah, I never fully understood it. Okay. But yeah, I guess the one really good, or I guess the two big advantages, right, is that this thing's already set up for you, right? You don't have to worry about it, and it's also well integrated with the language, right? So if you're already using C++ features, then it works well with it. But yeah, again, still, I am gonna write my own, just for the knowledge. So you write a stack allocator. Sorry if I don't see the comments. I'm just looking through the video. Deallocate, allocate. Obvious mistakes. Rebind. What? It has an inglorious past, murky present. Insane. Is the S&D alligator? I was reading the first comment on the video. I'm dead, man. Okay. Yeah, I'm gonna save this. I might just take a look at it later. But again, I am determined to write my own. Let's see. I am probably misremembering, but from what I recall, the talk covered... Let's see. Oh, I think I missed a few. Let's see. Once allocator composed well, you don't need the flexibility. Majority, for example, believe a simple allocator benefits. I'm probably misremembering, but from what I remember, the talk covered very flexible allocation schemes that compose at compile time, which is fine. Allow you to quickly test and compose purpose-built or even class-dedicated allocators that's really useful, as long as it compiles down to the equivalent application issues. You don't need that. Take it inspiration, because you can write a small set of far simpler code-wise allocators. I don't remember the talk particularly well, but I might need to rewatch it. Yeah, no, I'm gonna take a watch through it, just for at the very least for curiosity's sake. So do you use that in your code, LabbyDev, though?
Your call has been forwarded to an automated voice messaging system. At the tone, please record your message. When you finish recording, you may hang up.
Also, I kind of want to see what you were talking about before we started talking about the current topic. Yeah, if you have test struct foo or reneva alloc, I only mentioned the alignment because it's implicit for 8-bit. Oh yeah, I remember now. So you were saying, and it's necessary to remember, for generic buffers it's fine, but casting to a uint8 or uint pointer is technically undefined behavior because alignment of int is greater than alignment of uint8t. Wait, why is that undefined behavior? I don't get that. I might have a misunderstanding of like alignment in general then. I have very little heap allocation if your strings were stack allocated or inlined. I got you. Yeah. Okay. Well, yeah, I'll take a look then. I am trying to get towards that anyways. Either doing stack allocations or using my arenas, one of the two. But try to get away from just random heap allocations. It's kind of the goal right now. Imagine an int pointer. Alignment of int is 4. So such a pointer can only point to addresses that are multiples of 4. 2 ints. Alignment of int is 4, so such a pointer. Like, I get what you're saying. And Black, I'm just trying to Process it. Otherwise, the pointer points to the middle of the two ends. Yeah, I can visualize that. A car pointer and sidecar pointer points to any address. Yeah, because if it's 1 byte, that's like the minimal like addressable, right? So you don't really have to worry about it. I mean, you could address things smaller, but as far as like getting memory wise, it's per byte. Yeah, at the very least for the actual offsets, right? It'd be weird. Okay, so I get the visualization of it, right? The one thing I don't get is exactly why it's undefined behavior. You know, like again, let me show you like my current understanding of what you're saying, just so like you get like where I'm at with that. Okay, so where's wait, is it D? No, it's X, I think. There we go. All right, so if you have right here, and then if we have like byte 0, and then we have byte 1, and then byte 2. So I'm gonna write this out. 3, 4, 5, not to scale, but whatever. Okay, and then of course, like if you have a car or whatever, a car is 1 byte. If it's just a simple car, it's not a wide car or anything. Or in my case, I'm using like a uint 8t, but yeah, of course, car has its own little overloads and everything and whatnot. Unside car, same size, but just signed. And then you have an int, right, which is 4 bytes for a regular int, unless it's like a different architecture and then they change that, but for the most part, it's 4 bytes, right? Okay. And then if you have, say, like an unaligned car that's like reporting to this address, right? This isn't aligned by 4, and then if I try to cast this part right here as an int, right? It's going to use these 4 bytes, 1, 2, 3, 4, but this is not aligned, right? Ideally, you would have it aligned 0 to 4, right? Or from here to here, right? But this one is like off by 1. It's kind of weird. But I mean, you still could access this memory, right? It would just not be efficient. I just don't get the jump to undefined behavior. Okay, let's see. So, car special reason to man. X64 handles this for you fine, as it can do unaligned reads. But that is a perf hit. ARC64 can also do unaligned reads, but Linux and most other tend to configure it to disallow unaligned reads by default. Is a hardware exception. Oh. And it's UB because if it's disabled in that case, then you're messing things up, right? I said ARC64 might mandate, but of course, if I'm writing this code, I'm trying to be as inclusive as possible. So in that case, if I try to take this code and then use it, like if I try to take this code and I try to like use this use case in a situation where the hardware is not kosher with this, then it could potentially break, right? So ideally, you would just try to match up with alignments and then keep pushing. Okay, I get it. Yeah, it was just the jump to undefined behavior I got confused about, but I get what you're saying. Yeah. Right, and then what is it called? The initial alignment to that like heap, that malloc call, or could be virtual if you want to get that like 4 kilobyte page or whatever. You can align that initially, and then you can do. You showed me that algorithm before, which it takes in the size and your desired alignment, and then it over allocates the buffer and then moves it over so that it is properly aligned. And that way, at the very minimum, your alignment will work for data sizes aligned up to that type. And you mostly have to worry about the biggest alignment, right? Like the biggest size. That's where you get the undefined behavior. If you get smaller sizes, and it might be less efficient, but at the very least, you shouldn't get weird UB. Each alloc should take an alignment because your current buffer offset could be unaligned at each point. Current buffer set. Right. So if you do a current alloc and you have because the current offset could be anywhere in the buffer, right? So you want to go ahead and align that subset of the buffer. That makes sense. Yeah. So you align the big buffer and then you align the small buffer. No, I get what you're saying. Yeah. Well, that's cool. I didn't know that either. Yeah, I think LaviDev, that was my understanding with that. But like I just didn't get, like you said, like unaligned reads and writes are inherently slower. That was my understanding of it. But yeah, I didn't know it was straight up undefined behavior in certain cases. So yeah, that's interesting. Okay. Feels pretty good. Oh wait, I'm gonna get some water, guys, real quick. Probably like a minute or two. So I'll BRB. Okay, I'm back, but I am doing a quick stretch break. Okay. Unaligned data is can be undefined behavior. I kind of want to see if there's any online resources discussing that too. I could read up on that later. strict alignment rules isn't. Without causing an effect due to the following. Oh, does this program have undefined behavior? He just goes through his program. Oh, that's for ARM, right? Let's see. Wait, where are we? Alignment. Oh, right here. Okay. Alignment and endiness. An axis is described as aligned if the address is a multiple of the element size. Size of the axis. 16 value must be loads and stores a pair of elements respectively to be aligned. The address must be multiple of the size of elements, not the combined size of both elements. Vectors and load stores. When the address is not a multiple of the element size, the axis is unaligned. But not to the unaligned access to a device region will trigger an exception. Okay. So, generally speaking, I mean, the main way to like curb this whole thing and like not really have to worry about it, right, is if I am doing one of these allocations, by default, if we're just doing a simple struct or whatever, it should or wait, where is it? Yeah, if I do something like this, it should already handle the alignment with this case, right? Now, of course, I need to go and process it here and whatnot, yeah, so I'll get to that. But as long as I keep that, and I'm if I'm just doing simple structs, this should work. Yeah, I don't have to worry about it. The cases where it's like an issue, is if I just try to do something else where I'm doing like a raw allocation and doing something weird with it, or I'm specifying like a specific alignment to do something funky. But again, I need to fully implement alloc raw. You can simply set alignment to 16 and not worry, same as the C runtime, but that wastes memory in Arena. Right, okay. Right. Well, the main concern with that, if you're doing SIMD or whatever, like setting all that up, is just to like manage your data, right, and make sure that you know like what you're putting together aligns, and then you can just do what you want. But that's more of like the use case situation, right? You want to deal with, rather than leaving the responsibility on the allocator. Yeah, like, and then of course you want to have the option to specify the alignment, but yeah, generally you just want to make sure the data you're pushing in is appropriate for that type of operation. So no, that's fine. Yeah, I like this. This is very clean. Very clean. Okay, wait. So let's see if this works. So this is garbage now, and then this returns the actual type pointer. So we'll say test struct. There we go. Test struct A. And a pointer. Okay, and then we set these values to here. And we have 3 of them. So we're going to do test struct A. Oh, okay. You know what? Let's just try this by itself. Then I'm going to try doing that multiple allocation thing and see if it works as well. And then I'm going to try and overload the buffer, and then maybe handle that in a few different ways. And yeah, all right. So let's make this static, because I'm testing it. I could also do an array, I guess. Yeah, you know what? Let's do an array of what is this? Test struct pointers. It's like 5. All test. Right. And let's come back to where I was. And instead of doing this, we're going to do s all tests at 0 is equal to that. Yeah, this is throwaway code anyways. I don't really care. Just do this. Yeah, there we go. And let's come down to the whatever is going on over here. And we'll say, I don't know, let's log it. kg log. Oh, that's not called kg log. I haven't been in this code base in a while. Kg info. Current value is what is it? Okay, test string test value. Just do that, it's fine. All right, let's just see if I get the correct memory. Constructor gets called and everything. Next thing, we'll try multiple values, and then we'll see what happens when we overload it, and we'll go ahead and handle that. No matching something. I'm missing a brace, huh? What do you mean I'm missing a brace? No. Token. Alloc size of this one. Type. The new. Ah. Gotcha. I think they have a plugin on Visual Studio where it lets you like it color codes the braces. I was gonna use it, but I didn't like how it looked. But maybe I should use it. You know what? What does that look like? Let me take a look. Oh yeah, to each line, and then yeah, fair enough. a lot easier to reason about. And the compiler probably knows how to deal with that anyway, so that's probably fine. Oh, I don't care about this. This is garbage. That warning's. I'm gonna throw this away anyways. No, I feel it. All right, let's see. I want to split that log too. It's getting a little too big. Wee. All right. Oh yeah, I forgot I was doing this. Let's not do that. Yeah. It's kind of obnoxious. Where was it again? Oh, I closed it down, didn't I? They're all KG info. Let's do KG info. What? Where did I put it? Test full object. Oh, this one, yeah. I could probably clean up some of this test code anyways. Let's get rid of some of this stuff. Button, window flags. Yeah, I think this was some old stuff I was working with. I don't need this anymore. Timers, yeah, no. Edit float. Yeah, I don't need these. Timers. I do want to keep this though. Yeah, I use this compile file sometimes. Critical log. Yeah, no, I think we're good here. Some of this stuff I can probably get rid of, but what is this again? Yeah, I don't think I need this. Yeah, I don't think I need this. Let's get rid of this. This is me testing some old UI stuff. I do want the splines one though. I'll use that later. Okay, cool. Yep. Yeah, these toasts are doing a little too much. Okay, I mean that works. Let's try multiple values now. So let's do this with like 3, I guess. And then what does this return anyways? it's a pointer to 3 objects. So then you can do wait. Okay, so we get this pointer, and then that becomes that. And then if you want to do s all tests, 1 is equal to s all tests 0 plus wait. Yeah, so this is a pointer to the original data. So we do that plus the size of test strict, right? All you need to do is .val. S test objects 0, 1. Oh. Huh. Is that how the multi-dimensional arrays work? Let's see. I look at the API. Do is S test objects, or the back end isn't multi-dimensional, but it lets you access it like that. Wait, so what is a pointer and array are treated similarly? Oh, right. Oh, okay, no. Yeah, I think I get what you mean. So, like, this whole expression, so tests 0, right? That returns this pointer, right? And then that pointer, which again, arrays and pointers are treated similarly, we index into this as an array, and we get the first element after it. Yeah, and then that would get that. Yeah, okay. No, I get what you mean. Yeah. So it's like an overload on the, yeah, okay. Well, not overload, but you know what I mean. Okay. So test 0. So this we don't need to specify because it's the beginning, but then if we do like s all tests 0 and then 1. Oh yeah, and then you're indexing it as an array. So yeah, the actual object is, okay, it is the actual object. I got you. Yeah. Makes sense. This is string 2. I could have just done this actually. All right. 7. Okay, and then let's just print all these. Okay, okay. Alright. Try it out. Okay. Yeah, this next week should be fun for me. There's a lot for me to think over. I think over the week I'll go ahead and start writing the rest of these allocators slowly. Oh, wait, what? Oh, yeah. And then it crashes because of the logger. So, oh, not the logger, the toast notification. Had to figure that out. But yeah, you're right. Yep. Now I'm getting tired. What's going on here? Because I called it Tess. Right? Yeah. Like, it's been nice. Alright, let's see. Let's stop this. And of course my notification. You know what, let me I have a way to not do this. My logger needs to be fixed. I have a way to not crash the logger. It only happens when I try and do it way too fast. There's a lot of solutions for that, but the easy way for me right now is just to use trace instead. Because this one doesn't post to the toast section. What? Right, just random data. What's going on? Gotta love it. Okay, well, for some reason we're writing out what the hell? They're the same logger. What are you talking? What are you talking about? Right? What? Okay, wait. Let me look at this data. What? Okay, now my thing is gone. Let me look at this real quick. So the first one, the current value is we're skipping the string, or we're getting like garbage, and then we're getting an integer, and then we're also getting, yeah, this is garbage data. This is, and then this one's like kind of fine. Yeah, I believe it. It should. It should be the same exact function. That's why. What? Oh, it gets stuck to that. Yeah. Oh, that's weird. Okay, hold on. What is trace info doing? SPD log. That should evaluate. This is doing the exact same thing, except this one generates like this whole log event thing. This one just does that, so I don't. What the hell? I mean, I guess I could try printf. Let's just do printf for now. What's the include for that? I always forget. I know IOStream is for C++. What's the one for C? Oh yeah, CSTD IO. Right, let's do some printfs. Let's see what's going on. The current value is. And, oh yeah, we can't do that. What is this string? It's a %s, and then test value is a float. Is it that? Or the decimal? Decimals. No, I forgot now. Printf. Printf. Float. Oh, okay, it is f. Yeah, that makes sense. Okay. I'm used to decimals, so there we go. And then test string to test val. There we go. Oh yeah, new line. You're right. Yeah, I always forget when I have this logger to do. You gotta use a new line. Is it C string? I think it evaluates to a C string. Yeah, I think it's implicit. But maybe I should make it C string. Why don't I make the overload limit? Whatever. Okay, let's just duplicate it. Why not? Bring it down. All right, we'll do 3 test 3. Yeah, I believe it is implicit though, if I recall correctly. But just for safety. Okay, let's see. If this doesn't work, then there's definitely something wrong with the memory. Printf requires an argument of car pointer, but has type. Oh, that one. Okay, so it doesn't overload. Okay. Well, good to know. All right, let's try it again. I'll have to. Okay, what? Why are we getting random heap errors now? Okay, wait. It was not doing that before. Let's just forget about this for a second. Let's just not do this for a second. Forget it even exists. And let's go over here. Let's forget all this exists as well. Because if we're getting random heap errors, then we could have to just rebuild. Sometimes it'd be like that. Okay, that time it worked. Okay. If I get rid of this, is this gonna go crazy on me? Yeah, I don't know. Let's see. Okay, that time it didn't. Okay, so it doesn't immediately corrupt. Okay, what if I close this? Is it gonna yell at me? Okay, no, I didn't detect any heap errors. Okay, well, sure. But then when I do this, I get heap errors? What? I'm gonna comment this out. It's kind of annoying. I think it was fine before. Okay, wait. Let's pause this. So I'll close this. Okay, let me see what I'm getting right now. Current value is 0. Okay, so we're not printing a string. We're getting garbage. And yeah, so let's mix. And then for some reason this one works. Wait, let me put a delimiter for this. So let's, yeah, I'll, okay, and then we're getting like heap errors, okay. Is the arena guaranteed to live for the duration of the program? Yes. Yes. Yeah, no, it should. So like when I call this, or wait, yeah, when I call the on initialize here, and we do this, yeah, like this will definitely like this happens on init for the whole thing. I mean, I can check it, make sure this gets called, so we'll do that, but I'm pretty sure it works, or it should. I don't know. Yeah, let's try to just print 1 though and see. And then also maybe do a print f. Yeah, I could be wrong. I'll do a bit of that. Okay. All right, let's see. Right. It's corrupted when we're reading it. And then maybe try to print out the objects in the init. Yeah, that's a good point. Start making functions out of this. Maybe I should. There's test code, whatever. Alright, let's print it out. Unless we don't call it. Okay. I was getting scared. I'm like, I'm pretty sure I call it. I'm pretty sure. Okay, okay. Let's see. So we call init. That should be fine. Call this over here. Set its values. Yep, no. This points to this, which is set, yeah. Okay, let's just continue and see what prints out. Yep, looks good. Okay. And then let's go ahead and run this. What's going on? Looks good. So it might be the extra values then, the ones that are getting indexed in, might have issues. So let's test that out. We'll just do one at a time. Right? It works. I don't know. Yeah, I'm confused. Let's see. Okay. So let's do this. Okay, so if I go here, oh, it's still null. But that's fine, right? Because we're not indexing into that. So that's not the issue. So we'll go here. We'll get this one. This one's fine. And then we'll go here. What's up with this one? Yeah, I mean, that's, yeah. It's there. And if I go here, yep, looks good. And then if I try and test it, now we're getting garbage. Whoa, what happened? Oh, okay, so maybe it's not guaranteed to live? Wait a second. No, wait, it's not. Wait, no, I just realized something. I think you're right. Hold on. Something you said earlier, I think you're right. Wait, I think... Okay, so this allocates it, right? sRandom mem allocate init salloc, right? If I go here, it's static. What? This is static as well. Right, yeah, wait, what? Where's the RII? Wait, what? It's static though. What the? Okay, wait. Okay, wait. Okay. Let's. Sometimes I feel like when this stuff happens, just gotta clean the solution. Gotta rebuild it. Maybe something just something just went crazy. I feel like this is one of those times where I feel like the code's trying to make me insane. So let's see if that fixes it. If not, could you print out the pointer in all tests? Right. Yeah. Look, I could try that. I know this one. It's %p. I do know this one. All tests 0. Right, but like, what's corrupting it? I don't know. Because it gets allocated. I don't call free or anything. I mean, if anything, this is just a memory leak, but it's a static memory link, so I don't really care. Or at least for this testing scenario. Let's see. %p. Pointer arithmetic. So we do s all tests 0. Because if we index into the array, it's going to give us the actual reference. We want to do plus 1, right? Because this is a pointer to a test struct, right? So if I do +1, it'll index to the next one. Yeah. The point of arithmetic, sometimes it confuses me. Okay, there we go. +1, and then the next one's be +2. Yeah. So we'll do this. Okay, +2. And then %f, or %p. There we go. And then take this and copy it over. Okay. And we'll go ahead and let that build. Yeah, I don't know. I'm still thinking. I can't think of anything. We're definitely calling malloc, right? I mean... Right? Wait, unless... Wait, this is a pointer to this allocation. Yeah, which exists inside the buffer, so nothing would fall off the stack or anything. Yeah, what? We're not referencing anything local. And then it works, like, for this one, but then all of a sudden it doesn't work when you call all three. Do you get it? Oh, is that the problem? Oh, maybe, yeah. Yeah. No, it doesn't take in alignment. That's the problem, isn't it? Let's see. It's compiling, so it's not. Let me go find it. Yeah, so it's 48 bytes, alignment of 8. I mean, this is 32 bytes string in a float. right? So 36 bytes. Wait, 36 bytes. Maybe that is a problem. And one thing I could do, I could... Oh, but it claimed 48 bytes. Yeah, yeah. Yeah, size is 48 bytes. Yeah, no, it's, yeah, it just has this padding at the end. I mean, one thing I could try is maybe just get rid of this and then just try the 32 by itself. I mean, that shouldn't have any issues, period, right? Oh. Okay, what didn't build? Main window. And that is quite the linker errors. Unresolved link. What? What are you talking about? Divisible by 8. Okay, yeah. Like the actual padded version is good, so that shouldn't be the problem. Okay. With these linker errors. Open asset in editor, huh? This is the editor code too, huh? This is for the testing app, right? I think my testing codes have a linker error, so I'll check that later. But I think the actual editor is fine. Yeah, editor testing. Okay, I'll check that later. That's fine. It's probably just something I forgot to add into the build files. Okay, well, let's just check it. Let's see. Hmm? What is going on? I'm just getting random errors now. Gotta love it. Shirt pointer. Draw debug lines. What is going on here? What? Yeah, I feel like there could be a lot of problems with this. Let me see. This is why I gotta get away from these shirt pointers.
Here we go.
Lifetimes are weird, man. Let's see. History, transform, matrix, texture, shader. What's going on? A shared pointer to a... it's just debug lines. It's just grid lines. Yeah, I don't know where this error is coming from. It's like, wasn't an issue before. What? Right. This is like, this has nothing to do with the arena code, so I'm like, what changed? Oh yeah, maybe the arena code is writing to places it shouldn't be. Wait, but isn't everything padded in the debug build? I don't know. Let's see. Let's see. Well, I guess that makes sense because maybe it cleaned it up and then it rearranged the memory layout, and now it's writing to another weird place because it's doing a weird heap thing. So I guess that makes sense. Yeah, let me find my test code. Could just use Control T. Okay, yeah, let's get rid of this. Let's get rid of this test code. If 0 and if okay. All right, let's see if it works, or maybe I don't know. Yeah, I could try that. Let's just make sure this is because of this and not because of my poor coding. Okay, well, it works now. Right, yeah. Yeah, I was making sure I didn't like reveal some error that I did some long time ago and it's just rearing its head because I don't have any tests. Atrocious. Okay, well, alright. So yeah, it must really be reading or writing to memory it doesn't use, or it shouldn't be having access to. But yeah, I'm gonna take that advice you just gave me. Let me see. Let's figure out what the all test is pointing to. Test all tests. Wait, this is yeah, no, well, this should print it. This should print the pointers, yeah. Okay, let's see. Oh, okay, yeah. Well, real quick, let me see, because remember before, like it worked when there was only one value, but then all of a sudden it broke when all three of them, or you had like more than one. Right. Well, let's just see. Okay, yeah, we're just getting heap errors. Okay. Random heap errors of that. So the order must be like getting rearranged every time. And then it's just causing like random parts of this to fail. So yeah, something going on. Alright, yeah, let's get rid of these. If 0. Okay, let's take a look. Okay, and we are modifying these values still. So we might still get a memory corruption. Okay. So yeah, right. This is some crazy debugging for a linear allocator. All right, so we got a 3710. Let's see. Okay, these are all 3710. Yeah, it's the same memory address. Okay, but then we get a heap error. So yeah, we are writing over something we're not supposed to. So yeah, like it read fine, but yeah, that initial write must have written into some weird heap. That's why we're getting this error. Okay. So, right? Yeah, are we allocating enough size? Yeah, this one, it should be buffer size. Size. Sure, it's fine. Replace that size with a line next. Do you see it? Wait. Let me make sure I'm doing all this right. So we have data size and alignment, right? Data size is used here, plus the alignment, yeah. Alignment, sure. Alignment goes here. The return pointer is here. And then we return that. It's per byte. I don't see any issue with that. I don't know. You said replace that size with a line next. Split it out and debug the call. Okay. Right. I mean, yeah, something's definitely being written out of bounds. So, yeah, because we're probably getting memory that we're not supposed to use here. So yeah, something's going wrong here. I didn't think I should split it out. Just maybe because here we're doing alignment of test struct. Right. Align next. Okay. Let's try something. So, data size is this. So this will return the pointer to that. I mean, there's no way this is messed up, right? This is pretty cut and dry. Like data size plus alignment. So yeah, maybe it's just aligning to like a weird location. I don't know. Yeah, this is very cut and dry. So yeah, maybe let's try return pointer is equal to this, and then we'll return pointer. Wait, what? A type of view cannot be assigned to an entity of type. Wait, why can't I assign this? Oh. return uint. Oh, okay, so I can just do this. And then put it over here. Okay. Getting confused. All right, here we go. Okay, let's see. This thing's gigantic. I'll just look at the memory real quick. Okay, here we are. So data size is 144. That makes sense. Alignment is 8. Cool. All right. We get back this. This should be very cut and dry. 296111. How do I look at the? I always forget. There's a way to look at the memory here. Not disassembly, that's the assembly code. How do we look at that? I think it's in tools. Because I could just ask ChatGPT or something. Oh, window. Analyze, code cleanup. Yeah, I always use this thing and then I immediately forget where it's at. Memory. There we go. All right. And then how do I address is here. What is this type again? The uint pointer T? I'm pretty new to using this one. Uint pointer T. So this is the actual memory address, right? I'm assuming. Okay, so can I just take this number and put it in here? This is in decimal. I should probably change it to hex, but right. Okay. There should be a way to like automatically do it, but I'm just gonna find a calculator. Decimal to hex. Okay, and line to here, that's probably what I want. Okay, so that's a lot of CD bytes that we got back. Okay, and that is here. Okay, and then let's check this pointer after this. So we're gonna do this. Okay, where does this go to? 0688. 0688. Let's get that to hex. Zero 688. Wait, what? It's the same thing? Oh, well, yeah, in this case, it's the same thing. Yeah. Because it's already aligned. (16-byte aligned, right? I always forget. Hex is the 4 bits, right? So hex is half a byte. So byte. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, it just returned the same pointer, right? So, because the numbers are the same. So it must have already been aligned. So, and it looks like the malloc returned the correct amount of data because it's CD'd And how many bytes did it request? It requested 144. This is. I'm assuming. Wait, is this 64? 1, 2, 3, 4, 5, 6, 7, 8. So 8. 16. Yeah, looks like 64. Yeah. So 64. 128. Yeah. Okay. Yeah. There's no way this failed. Step into the arena in it. Okay. Let's see. You can go back up. All right. Okay. So. Yo. What? Is that right? That was weird. I mean, it will assign it. I know that. So now this is that. The buffer size is 144. Yeah, no, that's fine. And the offset is that. What is this data pointer? It looks like uninitialized memory. Yeah, it doesn't look right. Or wait, no, maybe that is CD. No, maybe that's right. Maybe that's right. Malik is uninitialized. Yeah. And actually, those bytes, the CD, I'm assuming that's what these characters are. And then it goes up for a really long time. And then you end up with these Y things, which I think is the random memory. Yeah, so no, I think that's fine. Yeah. I mean, yeah, it sets the pointer, sets the buffer size, sets the offset. I don't see the issue. Okay, so maybe there's something wrong with the alloc. Yeah. Let's see. So type pointer. Okay. Go into alloc raw. Yeah, maybe I wrote this code wrong. I don't know. M offset plus data size is less than or equal to M buffer size. So yes, right? M offset plus equals return M buffer plus. Bruh. Wait. Yeah, okay. No, this is the issue. This is the issue. M buffer. Okay. Gotta love it. Gotta love it. Okay, M buffer plus. See, this is why I test. This is why I test the silly. I'll do something like this. Okay. And then we gotta move this down because this is not the right offset, so let's see. We want to cache this location. So we'll say uint8 underscore t return val is equal to M buffer plus offset. Yeah. Okay. Then plus equals and then return. Can't mess this up, right? Right. Oh, okay. For sure. All right, so yeah. Okay, let me make sure my brain is not like this is the simplest thing ever. Okay, we make sure it's within the boundaries. Sure. We get the current location. Okay. Move the offset forward. Return the current location. Yes. All right. That explains a lot. Okay, let's just try it. Let's see. Okay. I mean, the normal one looks good. That's not really the issue. Let's get back here. Where did my code go? Oh yeah, and then that would explain why we kept seeing on the third value, we kept seeing like some correct values because it kept in yeah. Okay. Sure. Okay, yeah. There we go. And let's see. All right. Nice. That must have been the most painful linear allocator. Okay, I'm just glad that's good. A lot more features I could add to linear allocator, but I'm just glad that works. Okay, only took 4 hours. But I don't think it was wasted. Yeah, I definitely learned a lot. All right, but yeah, I think I'm gonna call it. I think I hit my 5-hour mark for today. Let's see. So let me go ahead and do my end of stream stuff. Yeah, no, thanks for coming by. It was fun. Right? Oh yeah. Okay. All right. So I'm not going to push any of the code right now. Nowadays I push the code after the stream. So plus this is on a different branch, so I'll deal with that myself. Progress board's about the same, so there's not much to really update, but we'll take a look. So yeah, so for the next week or so, I'm going to try and get these done myself off stream, and then I'll either do an update or I'll continue working on the next stream. We'll see. And I'm also going to start working on my networking code off stream, and then I'll kind of let everyone know how that goes. Is there anything else I wanted to talk about next stream? Yeah, next stream will be next week. Friday, same time, 5 hours. So yeah, I think that's gonna be it for me. For everyone, if anyone's sticking around and they're just chilling, thanks for coming by. Thank you, Mblack, for sticking with me. Appreciate it. Yeah, I think that's gonna be it for me for today. For sure. All right. Yeah, I think that's it. So yeah. All right. Later. There we go. Oh, thanks for the follow. Hell yeah. Nice. All right. For all this time. Later.